All right, welcome everybody to the second quarterly meeting of the California Water Quality Monitoring Council. This is the second meeting and completely virtual and abbreviated version of the meeting. We'll be focusing on a great set of groundwater monitoring talks today. Let's see. So before we get started and dive into the agenda, I'd like to take a moment to acknowledge tribal lands in California. The California Environmental Protection Agency and the Natural Resources Agency are located in Sacramento. Sacramento was and still is a gathering place for many local tribes who have lived throughout the Central Valley and the foothills for generations and were the original stewards of this land. These people include the Nisenan, Maidu, and Miwok peoples and the Patwin Wintun nations who have remained committed to the stewardship of this land over many centuries. It is important for us to recognize that our organization sits on the tribal lands of Indigenous people and that we are here because of the sacrifices forced upon them. In acknowledging and remembering these communities and all of the work we do, we hope to honor their legacy, their lives, and their descendants. For those that are interested in looking into the lands that they live on or work on, there's a great link there, native-land.ca. All right, first, a little bit of housekeeping. This meeting is being recorded, so please mute your mics unless you're intending to speak. If you are speaking and you're comfortable doing so, we would encourage you to turn on your cameras. We're going to do a little bit of a roll call for the council members on the call. And for those that are non-council members, go ahead and use the chat or update your name in the participant list to put your name, preferred pronouns, and organization you work with. My name is Nick Martirano, he, him pronouns, and I'm the director for the Water Quality Monitoring Council for those that are new here. So with that, I'll go ahead with the roll call, starting from the top. California EPA, which would be Greg, who's on here.
Sorry. Hi, I'm Greg. Here, work for State Water Board, confused.
Yeah, it's okay. Greg's here as the alternate for Karen Bogus, who couldn't make it today. Natural Resources Agency is our other co-chair position. A little bit of a pre-update is that we did identify Jen Eckerly, who accepted to take over the role that was previously filled by Mark Gold as the co-chair and representative for the CNRA. She likewise, because it was kind of a last minute, could not make it. I think she has a meeting that conflicts here, but we did meet with her and she's excited to take part and include our partnership with the Ocean Protection Council. Josh Grover is currently our alternate, but I think we're looking into seeing if he still wants to fulfill that role. Next up, the drinking water program.
Hey, this is Andrew Altfolk, Assistant Deputy Director of the Division of Drinking Water at the State Water Board.
Thanks, Andrew. Public health, likewise, I've spoken to them. Both Anthony Chu and David Mazira couldn't make it today. Our previous seat that was filled by Mark Starr is now a retired annuitant, and he might pop in to see what's happening, but they are not here.
I'm actually here, Nick. This is Mark. So
hey, Mark, welcome back.
Thanks. I'm happy to listen in and appreciate the opportunity.
Thanks, Mark. Next up, regulated community, the publicly owned treatment works, wastewater.
Hi, Lorian Fono with the Bay Area Clean Water Agencies.
Hi, Lorian. Next up, regulated community stormwater.
Hey, good afternoon, everyone. Grant Sharp with Orange County Public Works, representing the regulated stormwater community.
Thanks, Grant. Next up, agriculture.
I'm sorry, Nick, did you want, I think Brian Lawrenson is also on as well. Did you want?
Sure, if he wants.
Yeah, go ahead, Brian.
Oh, thanks. Yeah, Brian Lawrenson, Larry Walker Associates. I'm Grant's alternate in stormwater.
Thanks, Brian.
Agriculture. Hi, everybody. Mark Cady, California Department of Food and Agriculture.
Hey, Mark. Next up, community monitoring groups.
Hey there, Helen Patanides with Sierra Streams Institute, representing community monitoring groups.
Hey, I'm glad to have you on. The public, I know Ray isn't here, but I believe his new alternate, Fred, is online. Fred?
Hello, Fred Briones, tribal member at the Big Valley Rancheria Band of Pomo Indians located in Lakeport, California, Northern California. Thank you.
Thanks, Fred. Scientific community, non-academic.
Hi, Steve Weisberg from the Southern California Coastal Water Research Project Authority.
Hi, Steve. Scientific community, academic.
Hi, I'm Krista Kamer. I'm the director of the California State University Council on Ocean Affairs, Science and Technology.
Krista. Water supply.
Hi, everybody. This is Peter Broom, Deputy Public Utilities Director for the City of San Diego.
Thanks, Peter. And we're still working on nailing down who will be our EPA liaison. But we've been in talks with EPA to identify the right person, but hopefully we'll finish that up soon. But thanks everybody for joining today. So the agenda review, send out the agenda. It's been posted. There's no changes or adjustments at this point. A little bit of a rundown. This agenda was co-organized by Mark, Katie, and Andrew Altavote, along with some help from myself. We're focusing this meeting on groundwater water quality monitoring, with the idea that we primarily focus on surface water within this group, and we wanted to kind of look in that other aspect of water quality within the state. So we're going to start off with the first item after announcements is going to be focused on just kind of laying a baseline for what how groundwater differs from surface water, the interactions. We're going to hear from Thomas Harder from UC Davis, who's been kind enough to grace us with this time. We also have presentations from our two biggest agricultural regions in Region 3, the Central Coast Water Board, as well as Region 5, the Central Valley Water Boards, to kind of give an idea of the water quality monitoring that they're doing within their regions. And then we'll also hear from an ag coalition that does some of the work within Region 5, the Central Valley Water Board, as well as the community from the Community Water Center. Keisha Rivers is going to talk about the community aspect of groundwater monitoring. And then we'll hear from Dorian Bell from DWQ and the GAMA program to talk about the tools, what the data is used, how it's visualized. And we'll hopefully have a good conversation and a lot of great information and enlightenment within the groundwater space. The action items, there really wasn't much of an action items from last meeting. It was basically to work on this agenda. So there weren't really much in the way of action items. So those are finalized as well. So with that, we'll move on to the next agenda item, which is the public forum. So anybody that is on the call today that wishes to speak to the council on topics that are not on the agenda, please go ahead and raise your hand in the participants list, and I will call on you. You have 5 or 10 minutes to hear from you all. All right, well, not seeing any, so we'll go ahead and move on to item 3, which is member and director updates. So we'll go ahead and do a round robin of updates from the council members and their alternates to just enlighten folks and the council members on kind of items that would be pertinent to the group. Let's see, we'll go backwards from this time. So we'll start with water supply.
Sure, thank you, Nick. So not a whole lot has been happening. The two co-chairs for the what is now the equity, is it subcommittee or working group? I can't remember which term we use.
Work group.
Work group. So that the both attended the National Water Quality Monitoring Council conference. Nick was also there, and they engaged in some of the equity efforts that are going on a national level. They were both really excited by what they learned and happy to come back, and hopefully they will be applying some of that knowledge to our equity working group. And other than that, there's not a whole lot to report.
Thanks, Peter.
Sure.
Go on to Krista. Anything from?
Thanks, Nick. So I just want to say that Coast is really interested in topics around sea level rise, concomitant groundwater rise, where the groundwater is being forced up in coastal regions because of the pressure had from sea level rise, and then mobilization of contaminants as the groundwater reaches new levels and also changes the speciation, particularly of metals. So if that's anything anyone is interested in, please go ahead and get in touch with me. We're working with academics, community-based organizations, particularly in the Bay Area, and some state agencies, not necessarily those that are here, to try to put together funding for different projects that we might do in regional areas. So sea level rise, groundwater rise, and contaminant mobilization. Thanks.
Thanks, Krista. Next up, Steve. You're muted.
Yeah, probably a lot of people wish they could do that to me. So actually, I want to report out on something I think is a great success of the council. One of the things that we have done is create a molecular methods work group to kind of get ahead of the curve on molecular methods that are coming down the pike. Because of that group, which actually I think is meeting right now, I'm the liaison to that committee. I think they're literally in the meeting right now. We were able to attract the National eDNA Conference to California last fall. And the people who are part of our work group were a big part of that meeting and essentially convinced the federal government that this technology is ready for adoption. And there's a need for basically a national strategy. The outcome of that meeting was so successful that the White House has decided to develop a national eDNA strategy, how they're going to roll it out, how they're going to support it, including some of the technical things that need to be done, but really how they're going to support it, how they're going to try and create an industry around it. And the Molecular Methods Work Group from California was a big part of making that happen, so much so that Susie Thoreau, who is the chair of that committee, that working group for us, was one of half a dozen people who was asked by the White House to contribute to the national strategy document. So not only did we help it get to the point of being that way, but now the ideas that come out of our molecular methods work group are going to find their way into the national plan. California is basically leading the way in helping make that national plan happen. We don't have that work group. We don't have that level of influence. So the work group has just been astounding. They probably have 100 people on the call today. It's done everything we had hoped it would do, is bring the community together and start to develop consensus and approaches before everything was done differently, rather than having to fix it at the back end, which is where we get caught with doing most things. So just a heads up how well one of our committees is doing.
No, thanks, Steve. I couldn't agree more. It's unfortunate that it was an overlap because I really enjoy attending those meetings. And it has been a huge success and really an example of how the council has changed its focus and provides value to the state with these new and emerging methods and technologies. And that's great to hear. I hadn't heard about the national strategy and that Susie was tapped for that. That's fantastic. Thanks for that. I see that. So Helen, no updates from Helen and the community monitors. We'll go ahead and hear from Mark Katie.
Well, I could have written in the chat that I don't really have any updates either, although that news about the molecular methods is pretty exciting. That's great. Congratulations.
Yeah, they've done, for anybody that's getting into that realm within your sector, that work group has created a bunch of great standard operating procedures, and it's a great place to start. They've got, if you're thinking about dipping your toe into eDNA, we should reach out to Susie Thoreau in that work group. Okay, next up, let's start with Brian or Grant.
Sure. Yeah, just a real quick update on the California Stormwater Quality Association, otherwise known as CASQA. CASQA has rolled out a new website, and there is a seminar coming up on July 13th. These used to be known as the quarterly meetings, but they're now called seminars. It'll be held from 10 a.m. to 3 p.m. on July 13th. And there's no draft agenda for that event yet, but right now the topic for that seminar is going to be exploring key issues in stormwater management. And you can register for that event, but like I said, no draft agenda yet. I expect one fairly soon. And that's all I have. I'll turn it over to Brian.
Yeah, thanks, Grant. Just a couple of things. I don't know if you didn't mention the CASQA conference is in the second week of September in San Diego. People are interested or in the area. It's a great conference. And then also CASQA has two new program directors or program managers, forget the title. Evelina Mikowski came from the Ventura Stormwater Program and now filling a role. And Joseph Draper came from the Fresno Stormwater Program. And they work directly for the executive director, Karen Cowan, and sort of implement the strategic plan of CASQA, which includes interfacing with all of CASQA's subcommittees, which includes a monitoring science subcommittee and a number of other ones that are sort of relevant to this group.
Thanks, Brian. Thanks, Grant. Grant, I did see something that come across when I was on the SMC. Isn't there a webinar or something happening in your neck of the woods that your group's putting on? That might be of interest?
Yeah. Thanks for plugging that, Nick. Actually, I can share the flyer, or if you already have it, feel free to share it with Monitoring Council. But the Metropolitan Water District of Southern California, they host a series of webinars to feature projects funded through their Future Supply Actions program. And there's a webinar upcoming in a couple weeks on June 15th that will look at a project done in partnership with Orange County Public Works and Molten Miguel Water District that essentially the goal of the project was to deploy sensors throughout a watershed to be able to feed data into an analytics platform that would allow end users to measure, quantify changes in runoff conditions in terms of looking at effectiveness of runoff reduction strategies that might be implemented within those tributary areas. But really the main goal of the project was to inform where water supply projects or stormwater capture projects that would benefit water supply could potentially happen. So very exciting to see that project completed and now fully operational. And so that webinar on July 15th will kind of highlight what was funded by that MWD Future Supply Actions program.
Cool. Thanks, Grant.
Thanks.
All right, next up, either Sam or Lorian, or both.
Sure. For those of you who didn't get enough PFAS last time, I wanted to just give a quick update. The Region 2 special study looking at sources of PFAS to sewer sheds as preliminary data, which is going to be public within the next month. We looked at purely residential sub-sewer sheds to get a sense of the background signal coming from consumer products. It looked a lot like what we see in plant influent. And this dovetails with the statewide effort looking at the data that came from the investigative orders, with the intention being that we can disambiguate between PFAS coming from everyday products that we're all using that have a down the drain route to those that are being used in industrial applications that can be targeted with pretreatment programs. So I'm happy to give more information on that once the data has been synthesized and published. Thanks.
That's great. Thanks, Lauren. Sorry, Sam Choi, I missed you on the introductions, but
No problem, Nick, and I got no update. Thank you.
okay, thanks. See, no, Mark, I don't know if you have anything from the public health side of things, Mark Starr.
No, public health doesn't have any specific water quality updates to report for today's meeting.
Great.
Thanks, Nick.
Thanks. And that really leaves Greg.
Looks like everything I would update on you have in yours, so I'll let you do it, Nick.
Okay, fair enough. Let's see. Okay, so my updates. We'll start with the 2022 Water Data Challenge update. I think I spoke previously in our February meeting about an event that was supposed to be this month, where we were going to wrap up with an award ceremony and just a further discussion into the projects that were came out of the Water Data Challenge. There were 5 different unique projects that came out of it. We've been working with our partners at the Big West Data Hub, and we've actually shifted gears, and we're going to actually have an in-person meeting down in La Jolla in August 9th and 10th. And I can put in, maybe Greg can help me put it in the chat, where we will we'll focus it's like a day and a half. So the first half day, it's from like 12 to 4:30 or 5 that we're looking at, where we'll really dive into the Water Day Challenge after some keynote speakers on water quality data in general, and open data, and then have the kind of judges get to talk to the actual data project developers and ask them questions before they go off that evening to judge, and then come back the next day with not only kind of kick off with the award ceremony, but then the rest of the day is really going to dive into several different panel discussions on water data that we're still developing kind of the agenda and who's going to speak, but it's really going to have a focus on the communities that are collecting data, as well as kind of the sectors that are developing the data, and really provide a great networking experience for various levels of people and students, whether that be in high school and as well as some of the local colleges that are coming. And so it's going to be a really positive experience to hopefully keep the movement of open water data and utilizing the data that's out there, and then innovating to help us better answer our questions. It is open for registration. We're still kind of keeping the focus a little bit smaller, but it is going to be a great event for those that are around there coming up. And then the National Water Quality Monitoring Conference is, I went and attended that. I helped plan that event as part of my role as the EPA Region 9 state representative on that council. It was a great turnout. We were in Virginia Beach, and the weather cooperated while we were there anyway, but had a lot of great networking events. I spent a lot of time in the equity space and networking with folks in that area. There was, great representation from SQUIRP I saw there. Like, as Peter mentioned, he was able to send a few staff from San Diego, and I think they got a lot out of it. And, I'm hoping that we can figure out ways to get more California folks to that conference. It's really difficult for at least our agency to travel out of state, but we're working on it, and hopefully in the next couple iterations that we can maybe bring it back to California or to the West, where we can maybe make it a little bit easier. With down that vein, the 2024 NOMS conference is going to be at the California-Nevada state line in South Lake Tahoe in November of 2024. So that's going to be a great opportunity to get some of the state and regional and local folks from California to attend a national level conference. I think the save the dates are out on their website, but I can also disseminate that after the meeting. But that's a great one to kind of mark your calendars, and hopefully you can send some staff or yourselves to go chat with some state and federal counterparts. Some of the other work I've been doing has been focused on the Water Board's Racial Equity Action Plan, specifically a data action plan, which the Office of Information Management Analysis, which is the office that Greg is the director of, and I work for Greg. We are tasked with developing a data action plan related to racial equity data. So we've been working on an internal team to develop best practices, as well as a coalition of resources and tools that are being utilizing racial equity data. That will be have some externally facing information so that it can be used by not only the Water Board staff, but people, anyone interested in utilizing racial equity data and finding resources. So that's a big part of something that I'm working on now. And then the other kind of big thing that would be of interest to this group that I brought up last time was the My Water Quality webpage updates. Several work groups have already put up drafts that our Division of Information Technology web developers are working on, specifically Safe to Eat work group, the Environmental Flows work group, the Wetlands work group. I think the Estuary work group is working on one, and I've developed and submitted the kind of a overhaul of the landing and About Us web pages, and kind of thinking about ways to display you all and your information as well. So they're actively working on that. We hope to get some of the other work groups on board, some of the less active ones, and hopefully we'll have some beta versions out by the next meeting in September that to have you all to look at. I'm seeing a note from Safe to Drink. There's a draft of a draft that's been worked on by them, so we're working on it. That's a team of 1 or 2 people, so but we're doing the best we can. With that, that's the end of my updates. If there are any questions for me on any of those updates. All right, well, great. We're a little bit ahead of schedule, but hopefully, Thomas, I saw that you were here earlier in the participant list. Are you willing and able to kind of present a couple minutes early?
Yep, I'm ready to go.
Okay, then I will stop sharing.
Just a second and I'll be ready to go here.
No problem. Thanks again for agreeing to do this.
Yeah, thank you for having me, and thank you to Mark for getting me to join you today. I am Thomas Harder. I'm a professor at the University of California in Davis, working on groundwater at the nexus with agriculture. In that capacity, I'm also a professor of cooperative extension with UC-ANR that some of you might know about. And I'm an associate director with the Center for Watershed Sciences. I'm coming to you today to talk about groundwater monitoring, which is something that we've done a lot in my research group in conjunction with a lot of groundwater modeling. I came to UC Davis and the cooperative extension side in the mid-90s out of University of Arizona. And the interesting part that's relevant to this group is at the time, sort of the hip groundwater research that was done was really all around Superfund and Superfund sites. And of course, that all involved monitoring and modeling what we saw in these wells. And being in the Central Valley and working with folks in the Central Valley and looking at funding opportunities in the state, and also being embedded in cooperative extension, I very quickly abandoned the idea that I had originally come in to this work, working on Superfund site stuff, and actually started working on agricultural sites. And within the first year, Regional Water Board colleague approached me about a monitoring network that they had established on 5 dairies in the San Joaquin Valley, and asked whether I would be interested in taking that over since they were out of funding, which that was a great tool for me to work with. I've built much of my research work on that monitoring network, looking at nitrates and salinity and antibiotics hormones and whatnot across the dairy landscape, which then also got me engaged with Sue McConnell's office, Mary Hamilton's office, looking at nitrate issues, looking at salinity issues. And that was a fairly extensive exercise in monitoring groundwater around a non-point source. And we've since moved on to not just looking at dairies, but looking at other agricultural operations and trying to understand how we can monitor that. So I'm coming sort of with that bag of experience, about 2 decades plus in this arena. And coming at it from the groundwater side very much, and my understanding is that many of you are primarily focused on surface water. So I thought I'm going to do 2 things today. One is I'm going to give you a little bit of a background on why groundwater quality is important and to whom groundwater quality is important. And then give you in sort of the second part an overview of how I think about monitoring and how the monitoring that we do in the groundwater space is a very different kind of challenge from the groundwater monitoring that you might be doing in the surface water space. So with that said, groundwater, of course, the one key issue why we look at groundwater quality is because it's a key drinking water resource in California, but also nationally. In California, from a pure quantity perspective, a little more than 1/3 of our water in an average or wet year comes from groundwater, but then we get into dry years like the 2012-2016 drought or the last 3 years, where as much as 60% of our groundwater can be of our urban and agricultural water can be coming from groundwater. Now that's on a sort of statewide basis for developed water. If we look specifically at drinking water, over 80% in California, over 80% of drinking water users are some of the time dependent on groundwater. So groundwater resources and having groundwater resources that are of a quality that's suitable for drinking water is really important. At the national level, groundwater is also a significant source of water. About 90 million acre feet nationally of groundwater use, plus 210 million acre feet of surface water use. And that's broken down here into the various use buckets. And the one that I wanted to point out here is in the upper left. You have domestic water use and you have public water supplies. And you can see that there is the groundwater part, which is the brown part, is really the overwhelming source of water for all of the domestic water users. There is very little surface water being used on the domestic supply side. On the public supply side, it's nearly 50-50 at a national level, pretty much like what it is in California when we look at the actual usage. And there's probably a little bit less dependence of these public water supplies on groundwater at the national level than there is in California, where surface water supplies are not as steady as they are at the national level. The domestic water supply is quite extensive across the country. This is a map of the percentage of people in each county that use domestic wells, with the dark color being more than 2/3 of people in a particular county using domestic wells. California kind of falls on the low end, and that's because we have large counties, and most larger counties will have it at least one large urban center that completely dominates the population fractions in this particular graphic. This is a little bit better graphic showing the number of people that are in each county that are on domestic wells, and you can see there is a large number of people in California that operate on domestic wells. There is probably something on the order of, in the Central Valley, I know we have about 100,000 plus domestic well statewide. I think the number is closer to 250,000 or so. Globally, and that's where a lot of our research draws from, as well as research around the globe, domestic water use very much relies on groundwater. This is a breakdown of how much of the total water use in each of these 4 sectors that are shown here comes from groundwater. The darker blue, the color, the more groundwater. And again, on the domestic water use side, overwhelmingly people around the world depend on wells. So what do these wells tap into? Well, they tap into groundwater, and that groundwater can be of very different water quality kind and can tap into very different kinds of geologic environments depending on where you are. But in California, where the overwhelming amount of groundwater use is out of our what we call alluvial groundwater basins. Basically, what I like to call the bathtubs of California, where the bathtub walls are these mountains that we have, the Coast Ranges, the Sierra Nevada and Cascades, and the hard rocks of these mountains continue as the bathtub walls below our valleys. And these bathtubs are filled with sediments, sediments that have eroded off the mountains, or the wind blew them off the mountains, or they've settled in lakes in these valleys, or at times, and for the Central Valley, which this is a picture of, we didn't have the Coast Range, and actually the coast was further inland, and at depth we actually see unconsolidated marine sediments. But these unconsolidated sediments are what we would typically call dirt, made out of sands and gravels or clays and silts. They fill these bathtubs, quote unquote, and between these unconsolidated sediments, we have lots of pore space that is filled with groundwater. This is pretty much like you taking your flower pot at home, put a bunch of dirt in there where you cannot pack anything else into that flower pot, and then you pour water over it. And that water, even though that pot is full to the brim, you will pour water in there, and that water disappears into that pore space of the dirt that you just filled into that flower pot. And so this is basically an oversized flower pot with a lot of dirt in it that can be filled with groundwater. And when we drill wells into this, and this applies to the Central Valley as a large scale example, but it applies to all of our coastal basins as well. This happens to be Carmel Valley. You have mountains on one side, you have mountains on the other side, and in between you have these flat spaces. And these flat spaces are basically sediments that have been deposited in this bathtub. And most of groundwater is in the pore space of these sediments. Not to say that there aren't fractures in these rocks that we also use prolifically for extracting groundwater, primarily for domestic wells, not so much for large urban water supplies. So there's water in these bedrocks as well. And it is a concern as well in terms of water quality. So in the context of these basins, how does groundwater actually get into these basins? Well, it comes from recharge, and there's two major sources of recharge across all basins in California, all groundwater basins in California. One is the precipitation onto the land surface, or the irrigation on the land surface, to the degree that precipitation or that irrigation is not used by the plants or the crops or the ecosystems that are sitting on this land surface, or is not running off in an intense rainfall event to the next river, water will percolate through these sediments down to the groundwater table and fill this, or keep this groundwater basin full of water. The other source of recharge are the rivers that come out of the mountains. They when they come into the valleys, most of the sediments that we see near the mountains are coarse, sandy, gravelly sediments, very permeable. And so rivers up in these upper parts of what we call alluvial fans that skirt our mountains, if they're really flat. Most of these upper alluvial fans are very coarse, and rivers lose water out of these alluvial fans into the subsurface. So that's where the water comes from. And so got this flower pot, going back to my flower pot analogy, with dirt in it, you keep pouring water in it, and eventually, you know what's going to happen. Water's going to pour out at the surface. Well, in these basins, the first place where water pours out is in the lowest spot. And that lowest spot is, either the San Joaquin River or the Sacramento River, or in the case of the coastal basins, it's whatever river drains this coastal basins. That river sits at the lowest spot. And that's where the groundwater table is going to first intersect with the surface, and it's going to start draining into that river as the water table is higher often in the surrounding areas. Now, with groundwater pumping, we put a well into this dirt, quote unquote. that well is going to have a screen of a certain length, sometimes screened very long, sometimes screened and focused on a very specific area. These wells in California can be in domestic wells, typically from 20 to 100, 200 feet deep. In larger production wells, these may be 300, 2,000 to 2,000 feet deep, sometimes with long screens, again, as I said, and sometimes even in a 2,000-foot well, you might just have the bottom 100 feet screened because that's the only place you find some sand and some clean water. As we have pumped water out, some of that water that would normally go to the rivers is coming out at these wells. It's feeding our crops, it's feeding our urban water demands. Urban water demand doesn't evaporate, comes back into this cycle as wastewater, either directly into a stream or is actually percolating back to groundwater. And so that's sort of the bigger hydrologic cycle. And if you look at these landscapes across California, again, these flat spaces usually indicate that you have unconsolidated material under your feet with pore space filled with groundwater. The mountains are fractured. It's a little bit harder to get water out of there. The amounts of water that are in these fractures are much, much smaller than in the sediments. And so the reason why I'm pointing out the recharge here and where this groundwater comes from is because that also has to do with water quality. So if we look at, and this is a photo of the Central Valley, I'm sitting probably somewhere right near this water tower here in Davis. Here's the Sacramento, Sierra Nevada on the far side, Coast Range on the near side. This is that bathtub that I talked about, and it's filled with sediments. And the water quality of groundwater in these sediments is fundamentally determined by two factors. One, the water quality of the recharge that comes out of this landscape. And the other is interactions that water has with the rock pieces, with the sediment pieces that fill this bathtub. And between those two, that's what makes water quality. And of course, with Superfund coming around in 1980, one of our big concerns was with industry and urban areas in terms of water quality. Here's a picture, not out of California, but out of New Zealand, showing where you get a lot of recharge right as rivers come out of these mountains onto these alluvial fans. This is a great picture for me to sort of visualize how rivers recharge groundwater in the upper part of basins. And then, and this is the more local picture here in Yolo County with Poudre Creek this winter. Poudre Creek probably does a lot of recharge near the Coast Range where it first comes out of the Coast Range, but then coming out here in Davis, the soil is much more clay and there's going to be much less recharge nonetheless into the subsurface. Here's an image of what it looks like in the winter in our landscape, lots of recharge across agricultural landscapes, across urban landscapes. And one of our goals, of course, is to do more. And what happens in this landscape in terms of the interactions with what's in the soils is really important to water quality. And then here, finally, irrigation is another important part of our recharge. And therefore, what happens in these irrigated agricultural landscapes is really important to the water quality that we find in our groundwater basins. So in that context, you all work on the surface water side, and I'm going to oversimplify this for this, of course. You all work in the surface water context. We have national regulations, national legislation, Clean Water Act, others that deal with water quality and water quality monitoring. In the groundwater space, we don't have much of that national context. We do have the national context mostly in terms of Superfund, where Superfund essentially is a regulation to clean up highly contaminated industrial sites and regulate who gets to pay for that. But also as part of that regulation, we have stringent monitoring requirements that go with understanding what's actually happening at a Superfund site. These Superfund sites are typically local sites where you have an accidental spill that may have happened once, or it may have happened over a number of years, but you remove that source and it's basically over. And at that local site, the regulations that we have developed have all included groundwater monitoring with groundwater monitoring wells. Before I go into any more detail on this, what I thought might be helpful in sort of organizing monitoring both in surface water and in groundwater is to think about how regulations are typically structured. And I find a speed limit analogy, and I apologize to those that have seen me talk about this before if I'm repeating myself here. The speed limit analogy is really interesting because it's a very simple one, but it shows some of the basic elements that go into regulation. Somebody must have studied and looked at how the speed of moving objects impacts our health and determined that going too fast in traffic creates a health hazard. So there is an exposure by the population that participates in that traffic to these fast moving objects. And somebody did a risk analysis and looked at drivers and determined reducing the speed is a key tool to minimize these kinds of health hazards that traffic participants are exposed to. And in doing that analysis, perhaps parties, responsible parties have been prioritized. So we have a speed limit for trucks because they're heavier. That is different from a speed limit for cars. Of course, now you're going to have to make distinctions and you have to sort of diversify your regulation, and it gets to be a little bit more granular and therefore a little bit more expensive, perhaps. And once these drivers are identified, then there's key elements to the rest of the regulation. There's a responsible party. In the case of the speed limit, that's the driver. That driver is, in this case, the license. So a driver has to learn about how to operate a vehicle properly, has to show on a regular basis that they're still able to operate a vehicle. And we see very similar pieces in environmental regulations of all kinds. That driver is given tools to control the speed. So he has or she has a gas pedal, a brake pedal, and they can use that gas pedal and brake pedal to control that moving object. And in order to determine whether or not they are over the regulatory limit, they're given a speedometer, basically a feedback mechanism, a monitoring device that actually precisely monitors the speed of the vehicle so that they are able at any instant to do adaptive management in terms of how fast they go and control their speed. Part of this, I want to point out, is also that they regularly need to inspect a car and make sure that their car actually functions properly so that the brakes work and the gas pedal work. And they can, in fact, rely on these tools to work properly. In the case of the speed limit for enforcement, we have independent controls on that speed. We still do have that, although nowadays we would probably be able to put a little tag into just about any car and have that report back to the government if we were to choose that. And for obvious reasons, we don't. But we often have these independent enforcement tools, in this case, the radar control that randomly selects one particular object, one particular driver, and again, with some known precision, is able to measure the speed of that driver. In environmental regulations, we do exactly the same thing. And what we did in Superfund is we decided that we put monitoring wells upstream and downstream in ways that specifically target a particular source. But some of you that are involved in Superfund also know that there's always a lot of squabbling around really what are we seeing in these monitoring wells and who's really done that, whose contamination is this. And so that's where site characterization comes in importantly, and where we often end up with dozens, if not hundreds, of monitoring wells around larger Superfund sites. But then the other part is to remove the source and or manage the source in ways that prevent groundwater pollution. That speaks to having a properly functioning car, brake pedals, and gas pedals. In the case of landfills, again, groundwater monitoring is a really important tool, but we have these best management practices, or what we call best practicable technologies. And I apologize if I don't quite get this all right in terms of a regulatory framework, but we have basically rules around what somebody has to do in order to expose the environment to the least possible risk for contamination. We have, in the case of landfill, we have liners. In the case of a gas station, we have double walls for the gas tank, and we have leak detection valves, et cetera, et cetera. So best practicable technologies are a key part And then monitoring both within that best practical technology to make sure it works properly, as well as monitoring groundwater with monitoring wells. That has been the gold standard coming out of the development of Superfund and the regulations that we have in place. And much of the groundwater monitoring in California and elsewhere really has come out of Superfund and related programs. So let's look at what's in groundwater and what is of concern in terms of drinking water quality. Part, of course, is the chemicals that come out of these Superfund type sites, the industrial contaminants, primarily TCE and PCE. This graphic shows the principal contaminants detected in public water supply well. There is about 400 public water supply wells in the state. This report is now 10 years old, of which 1,700 have contaminated groundwater. These are this is before treatment. And the most commonly occurring contaminants are listed here. And not surprisingly, we see PCE on this list and TCE on this list, and we see benzene on this list. And some of these other industrial chemicals and their degradation product. But when we get to the top of the list, there's two other pieces that are showing up at even much higher frequency. One is these green bars, which are indicating naturally occurring or geogenic contaminants, including arsenic, gross alpha particle activity, that's radioactivity, uranium, fluoride, and chromium is also on that list. Selenium is on that list. Aluminum is on that list. And this is, again, not something that is unique to California. This is going to be as well at the national level. The other one, before I go to the next slide, in California, that's the top non-geogenic contaminant, the top anthropogenic human-made contaminant is actually nitrate, affecting a large number of wells. At the national level, we see a very similar picture. This is from a national groundwater quality assessment that was just published by Ken Balitz, who led the National Water Quality Assessment Program on this, that covered all the national principal aquifer systems. This is the total number of people that are affected by groundwater contaminants, almost 40 million people, the largest part of which is affected by geogenic contaminants. And about 7 million people affected by anthropogenic contaminants in their groundwater. And this includes both public and domestic water supplies. Actually, I take that back. This is strictly just public water supply wells, not including domestic water wells. The breakdown on the geogenics, very familiar from the previous slide: arsenic, fluoride, uranium, manganese, strontium, molybdenum, radon, and radioactivity. They are key pieces, and all of these are basically showing either being close to some health limit or above a particular health limit for each of these constituents and the number of people that are exposed to that. And then on the anthropogenic side, these are the organics, so typically associated with our industrial sites. And the second to last bar is showing nitrate, nationally also the #1 anthropogenic contaminant. Here's a map of nitrate concentration across the country, mostly associated with our intensive agricultural production in the Midwest, in the Central Valley, in some of the coastal valleys in California, also along the eastern shoreboard. Again, a problem that's not unique to the United States or to California, but is found around the world in many agricultural production areas. This is a risk map from the State Water Board's GAMA program showing the risk of nitrate contamination across California. Again, primarily in agricultural regions and some of the regions that had either previously significant agriculture or have dense urban development without wastewater treatment plants on septic systems. The trends have been there for a number of decades with respect to nitrate, long-term increases in nitrate across various regions here, again, for the Central Valley, primarily in the areas where we have the coarser soils, more intensive agriculture, and shallower groundwater. This red area are the east side fans in the Central Valley, and across north, central, and southern part of the valley on these east side fans, we see increasing fractions of wells that have higher levels of nitrate. This is also again shown on the State Water Board's website, which now features trends in all kinds of contaminants that you can easily map out. A lot of this diffuse contamination from nitrate affects our our most economically disadvantaged communities, and is therefore a key concern helping these communities deal with this particular problem. So how does monitoring come into place for these diffuse contaminants when we look at these landscapes? And this is nitrate, but this is also now salinity, which is Sue will talk about in the next presentation. How do we monitor these landscapes for contaminants that are in fact not just coming in from one particular facility, but across about in the Central Valley? I think it's 35,000 farms, about 350,000 individual fields if you count them all. How do you monitor what's coming out of these fields, and how do you deal with the fact that even within these fields, you got one soil on one side and you got another soil on the other side, and in the middle there's yet something else in terms of the soil, and they may interact differently with these contaminants and how they come out. And so from a mass balance perspective, we've done, as part of a nitrate report 10 years ago and then an update 5 years ago to the Fertilizer Research Education Program, we've done estimates of that nitrate loading based on mass balance, and people have since used models to refine these estimates. And you can see this is a highly variable source. And most importantly, it's not a one-time source. Agriculture is here, has been here for 100 years, and will continue to be with us. And we cannot isolate agriculture. We cannot isolate cities from groundwater to prevent this contamination. And so it's really about managing that contamination in ways that we can best reduce the losses of these contaminants into the subsurface. Now, in this case, just as with the speed limit, we have done the background work to understand where the sources are, what the sources are. There's septic systems shown on this map in olive green. There's cows shown here in brown, contributing to groundwater nitrate. There's fertilizer shown here in green, contributing to nitrate, and then there's natural nitrate background shown here in blue. We've done machine learning analyses to look at a number of different factors. We've looked at domestic wells and the land uses around domestic wells to estimate how much nitrate is lost from various land uses in the Central Valley. But that still leaves us the question with how do we, so we've done this part one, we've identified risk drivers and we can prioritize parties. So now, how do we apply monitoring in the context of non-point source groundwater pollution to deal with the fact that we have this highly diverse landscape with 250 crops, urban areas, lots of industries, highly different loading. This goes for nitrate, this goes for salinity. And then we got, as I said, 100,000 wells in the case of the Central Valley, domestic wells. We got about 5,000 public water supply wells and 15,000 agricultural wells that are going to be pumping groundwater eventually, or already do pump groundwater. In this landscape, there's a number of challenges. This is showing a research site that we have in an almond orchard. The grower in this half-mile by half-mile almond orchard, about 140 acres, is trying to have very uniform, both irrigation and nutrient management practices, highly efficient, actually able in these almonds to have a water use efficiency that's nearly 100% and a nitrogen use efficiency that's well over 90%. What I'm showing in this picture is the source area of our monitoring network. We have 20 monitoring wells in this 140-acre orchard, probably the most extensive orchard monitoring network in the United States. And the brown areas are showing the most likely locations of, based on our modeling, of where the groundwater comes from that we measure in these wells. And you can see that these monitoring wells, the source area is a relatively small area. It's not really representative. One well certainly isn't representative of the entire orchard. And it's therefore not surprising that the nitrate concentrations across this monitoring network actually varies by a factor of 8 from just below the drinking water limit to somewhere between 6 and 8 times the drinking water limit in the first encountered groundwater. Now imagine doing this not on 140 acres, but on 7 million acres across California. That drives you crazy, right? The cost, the analysis that would have to be done, and the backtracking. And so for a long time, we've been asking the question, how do we deal with moving from our ideas about how to monitor that come from a Superfund site and translate that into monitoring these non-point source sites. Another issue that we have to deal with is, this is an ongoing issue. This has been going on for some time. As we go deeper in groundwater, we encounter older groundwater. This is a graph showing the age determined from H tracer data, tritium helium H on the x-axis, and the depth of monitoring wells below the water table. And you can see this linear relationship between the age and the depth. In this case, where we go down to 60 feet and we're looking at 20-year-old water. And then you go to a domestic well, which might have its screen at 100 feet below the water table, and the screen is 30 or 40 feet long, and you can easily imagine what you actually get in this monitoring well. Not only is it not from yesterday, but also it's a mixed age. It might be, on the shallower part, it might be something that's 10 or 15 years old, and in the deeper part, it might be 30 or 40 years old. And so we're mixing signatures, and really the impact is one that is of land use over long periods of time. This illustration that a postdoc of mine produced a number of years ago by now shows the movement of 1 year's release of nitrate or salt from the water table through our typical heterogeneous unconsolidated aquifer systems. This is on a scale of about 4 miles from left to right and about 12 miles from the back to the front. You see 3 wells here. The red parts are their screens, and the colored particles are those particles that eventually hit one of these 3 wells, the blue ones on the right, the yellow ones, the middle well, and the green ones on the left well. And this simulation covers about 4 centuries. So we're talking about long-term contamination that's not easily cleaned up, and much of this might be stuck in sediments that are of low permeability. So again, going back to the monitoring of this and how we do this, we've done the background homework, we've identified vulnerable areas, and Sue will talk about that some more. Instead of that monitoring that we do at a Superfund site, we've replaced that with other proxies. One of them is understanding how well the source is managed through farm management plans and nutrient management plans. Another one is to, in fact, have a trend monitoring program across domestic wells in the region that look at particular crops or particular crop groups, but also make sure that we understand what's happening in our disadvantaged communities. And then the key remaining question is, how do we monitor in terms of what should the practices be going forward in terms of improving management, and then how do we know whether these management practices are implemented and actually have the desired results on water quality? So as part of this, in my research group and together with other research groups at UC Davis, we've come up with catalogs of practices that improve water quality. Myself and others are involved in a number of research projects, and Mark Cady from FREP is one of the funders for these kind of research projects, trying to understand the relationship between agricultural management practices with water and agricultural management practices with nutrients, and what the relationship is between understanding nitrogen mass balances on one hand, what's going on in the soil, and then what's happening in groundwater, and trying to show the relationship between these, in particular the relationship between the nitrogen mass balance and potential impacts to groundwater. Another part are modeling tools, and that again comes really out of the Superfund program, where modeling has always been a significant part of understanding what we see in monitoring wells. except for we're now operating at a much larger scale, large production wells, entire landscapes, entire groundwater basins, and we're developing tools to use that users can use to understand sort of the long-term implications and the long-term improvements that can be achieved with certain practices over the next 100 to 400 years. The boards are interested in getting water quality, groundwater quality, back to where it can meet drinking water standards. And a big part of this is going to be working with stakeholders, training growers, training those that actually manage the landscape. And that all has to be part of the package. And that's in my opinion, a slightly, well, it's a very different, it's not slightly, it's a very different approach from what we do in the Superfund site, where typically my colleagues will sit. One part of my colleagues will be representing the primary responsible party, or PRP, basically the polluter. And then some of my other colleagues might be, and I'm talking about my study colleagues from back in days when I studied hydrology, they will be sitting with a consultant for EPA, and they will, so expert talks to expert, and they will figure out how to manage this. And many of you are engaged in similar processes, say with wastewater treatment plants discharging into surface water. When we talk about these landscape processes and a large number of land owners and land managers being responsible for this kind of pollution, it takes a very different kind of education and outreach program and training ongoing programs to do this. And I'm looking forward to hear from our follow-up speakers on how they're doing this. Hopefully this has provided you with a little bit of context. I'm going to close it up here. And I don't know whether we may have some time for questions.
Thanks, Thomas. That was great. Really informative. Open it up to the council for any questions you might have for Thomas. Go ahead and raise your hands or put it in the chat. All right. Well, if anything comes up, maybe after they hear from some of the other speakers, their interest will be piqued, and I'll have some more detailed questions for you. But I appreciate it again, Thomas.
Thank you for having me.
All right. Let's see. All right. Next up, we have Mary Hamilton from Region 3 to give us an overview of the groundwater monitoring in the Central Coast. I think Mary's going to share her own screen, so I'll stop again. Mary, are you there? Maybe she's gone up. Oops. She came on, then I muted you on accident. There you go.
I was trying to click, and you know how it goes. I appreciate it. I'm gonna go ahead and share my screen. And just again, introduce myself, Mary Hamilton. I'm an environmental program manager with the Central Coast Water Board, and the Irrigated Lands program is one of the programs that I oversee partly here. Feel free to stop me if you have any questions as we go. I don't mind, or be happy to take questions if you have them later. And I just really put together some talking points for you to give you a really high level overview of the Central Coast Water Board's groundwater monitoring programs. Our largest program is associated with our Irrigated Lands program, but we also have a second domestic well testing program that is free for people who volunteer to have their wells tested. And eligible for this program are people who have private domestic wells or very small water systems, so serving less than 15 households or so. So I'll walk you through the elements of these two programs and then let you know what we're doing with the data and some other elements associated. So first I'll start with our Irrigated Lands program. Requirements here are necessary to, one, protect public health and inform well users of the quality of the water and the risks associated with any water quality problems in their drinking water. There's three elements to our Irrigated Lands program requirements associated with monitoring groundwater. The first one is that All growers enrolled in our order must conduct annual monitoring of their on-farm domestic wells, and that's all of the domestic wells on their ranches. Those samples are tested for nitrate and 1,2,3 TCP. Let's see what else. Their monitoring has to be conducted between March 1st and May 31st of each year. And then the data is reported to our GeoTracker database by July 31st. The growers also must notify all the well users of the water quality data and provide them with some health risk information. So we prepared some fact sheets that they share with those well users about nitrate and 1,2,3 TCP. And then the growers also have to report back to us in their GeoTracker forms and let us know that they have notified well users and provided them with the health risk information. And then the second element is also annual monitoring of the single primary irrigation well on each range. So whichever well they use the most, the primary irrigation well, they have to sample that as well. And that monitoring, they must analyze those samples for TDS and nitrate, and of course the fill parameters. It's the same sampling window. Data has to be reported to GeoTracker by the end of July. And this requirement continues until element 3, our groundwater trend monitoring program begins. And that starts phasing in next year. So element 3 is to develop and implement a groundwater quality trend monitoring program. And this can be done either for members as part of a third party with a single large scale monitoring program, or for people who are not members in our third party or coalition, as it's commonly called elsewhere, they must develop their own trend monitoring and reporting program. I mentioned that this is the requirement is phased in. So high priority areas, we're calling those phase 1 areas. And those groundwater basins have to be monitored starting next year. So their work plan to describe to us the monitoring well network that will be used and the type of follow-up that they will do associated with that. That's due to us later this fall, and we should hopefully be able to approve that and get this program going early next year. 2 years later, the phase 2 areas roll in, and then 2 years after that, phase 3. And then another key element of this program is that the monitoring must also have a approved sampling and analysis plan, as well as a quality assurance program plan that we will approve prior to the beginning of the program. So also wanted to just mention the primary uses of that data. I talked a little bit about, of course, we're informing the well users of the data. They receive fact sheets. We're conducting our own analysis, both of the basin scale and smaller local scales, to evaluate water quality, at a given well point, but also trends, both at that well point and throughout the basin. We're hoping to be able to track nitrogen reduction in those basins over time. And also we're looking for evaluation of compliance with our ag order targets and limits for the groundwater components in our order. We're also using this data to do some outreach with the county health departments. We're setting up a roadshow, if you will, and working with DFA to go to the various county health departments, share the data and information we have, and also share the available funding programs for replacement water and treatment systems. I wanted to point out that the data quality elements that the third party that we work with has already implemented, because they've done some above and beyond things that are not required by the order. And it really improves the quality of the information that we're basing decisions on. First of all, for all of their members, they're coordinating and conducting all the groundwater monitoring. So that's both the domestic well and the primary irrigation well monitoring. They're training their laboratories on the requirements. So the laboratories already are aware of what parameters have to be tested, what information needs to come back with those results, and how the growers are using the data so they can be working more seamlessly with those growers. The third party is also voluntarily collecting and analyzing blank samples and duplicate samples, because we do have that 1,2,3 TCP requirement, and the reporting levels are so low that they wanted to ensure whenever they're having a hit, so any detection essentially is above the MCL. They wanted to ensure that they had the ability to evaluate a blank sample associated with that, and also some other QC elements to confirm that the data is of high quality and usable and accurate. The third party is also reviewing the data. They're taking it, putting it into a single file, doing several quality control checks on the data and checking for completeness to ensure each of their growers sampled for all the parameters required in the right window and whatnot. And then getting it back to the labs to upload to GeoTracker. But what their efforts have done is informed, we call it a ticket or a request for GeoTracker to make a change so that they can accept a batch upload. Right now, what they do is they accept one ranch's data at a time, and they upload it one at a time, and there's a cost associated with each of those uploads for the lab. Sorry, for the grower, the lab charges a little bit for each of those uploads. But by doing this batch upload, we would prove our ability to QC the data, upload it all at once, and reduce that per sample or per ranch cost for the grower. So we're already working with GeoTracker to implement that, and we're hopeful that will be in place before this year is over. Let's see. So our domestic well testing program, switching gears to our second program. This one is not regulatory in nature. We provide free well testing to eligible participants. So those are folks who have domestic private wells or small systems. And if they would like to have their wells tested, all they need to do is contact us and show us if they qualify. This data is also being delivered to GeoTracker and available in the GAMA system. And the way we're making this free to participants is through settlement funds that are administered through the Bay Foundation of Morro Bay. So we've taken settlement funding, put it into contracts with these laboratories, and we're able to fund some free monitoring for folks out there who have small systems and otherwise would not be able to sample their wells. We're also doing this in coordination with folks at the Community Water Center of the Watsonville office. We contract with Tetra Tech to do the field work for us. And then we're doing some outreach work with the county health departments and of course, our own OPP and OPA offices. If you're interested, you can go to this website, centralcoastwelltesting.org. If you have friends and family who may qualify and are interested, they can sign up for well testing there. This program samples for a much larger suite of parameters. They're looking at not just nitrate and TCP and TDS, but also perchlorate, arsenic, chromium-6, and a series of general minerals. And this program also operates under an approved sampling analysis plan and quality assurance project plan. The uses of this data are very similar. We're informing the well users. We're doing our own data analysis to inform replacement water needs and working with the county health departments as part of our outreach to identify those areas that are in most need of replacement water and or treatment systems. And then of course, working with the Community Water Center, we're having a much better reach with our outreach to folks who are the non-English speaking communities and disadvantaged communities in the Monterey and Santa Cruz areas. And so that's really expanded our ability to outreach to those folks who need this the most. I also wanted to just highlight a few opportunities and stuff we've kind of got in the works and have identified as things we can do better or put into place so we can do more. We're constantly working with the GeoTracker team to think of cool add-on features or additional functionality that would make it easier for folks to have access to the data or understand the data and information and increase transparency. One big challenge we have run into was it's not a requirement of our program to include the georeferencing data, the lat longs. And so when that data is not included, the data do not get displayed on the awesome GAMA maps that the public can see and download data from. And so we've had a couple of people come to us with concerns that, hey, like you said, there were 700 samples, and when I downloaded it, we only saw 350. Where's the data? and we have to explain. It's different data that they can download on the public side than the regulator side, the side we have access to. And so just in working with GeoTracker to figure out how we can get more data in there that's visible. Can we snap it to the center of the property? How can we treat that data so that it can be displayed on GAMA? And trying to figure out how we can increase transparency for people downloading data so they can know that they may not be getting all the data that's available. And also I mentioned the chemistry batch upload tool. That will be a huge help for improving quality assurance and saving money for those growers who are required to do the sampling and upload it to GeoTracker. We're also doing some laboratory outreach and training so that we're improving consistency of the data. And when labs receive requests from individual growers, they're aware of what our requirements are and aware of what we expect in terms of quality and data reporting. And so that's really been helping with the consistency of the data and also just really clean deliveries instead of us having to follow up later. So we can do a lot more laboratory outreach. We're doing some, but there's a lot more we can do. And we intend to work a little more closely with ILRP to develop some outreach materials and make sure that we're speaking the right language when we're talking to our labs too. And then we're going to continue to identify funding opportunities, settlement funds, and things like that that we can use to assist both our regulated community and our small private wells and small systems. Right now, we've received a settlement from the Monterey County DA's office, I believe. And we were able to put that into a contract between the Bay Foundation and our third party and develop criteria for eligibility to use that funding for low-income farmers who are required to do the domestic well monitoring, and we're assisting with those monitoring costs. So that's one example of how we're trying to assist those low-income farmers who are required to do some of this expensive monitoring. The TCP is one of those higher dollar parameters. And that was the extent of what I put together in terms of talking points. I'll stop sharing, and if anyone has questions, feel free.
Yeah, thanks, Mary. Any questions? I have one, but well, I'll ask mine. Anyone else, feel free to raise your hand or put it in the chat. I saw one was already answered. But you mentioned for the well testing, Mary, the eligibility requirements, is it just serving less than 15 households, or is there income requirements as well?
No, for the free well testing, there's no income requirements, and it's either a private domestic well, so like one household, two households, or small system wells.
That's great. Awesome. It's a good thing, the resource that I'm thinking to put on the safe to drink. I get a lot of emails to me about how do I get my water tested, and it's usually at their own cost, but knowing that there's a program there giving back, that's fantastic. Anybody else? Any questions? All right, well, thanks again, Mary.
My pleasure.
All right.
Maybe if I can ask a question.
Oh, yes, please.
How does the monitoring program feedback to the growers? Is there a program that allows for some way to tell growers you're doing things right or you're doing things not right? Taking into account the fact that there's a long delay often between what growers doing and what you see in a well.
Yeah, excellent question. The trend monitoring program, the intent is to do exactly that, and it's going to be designed so that there is a feedback mechanism, and it is linked to our irrigation and nutrient management reporting for the various groundwater protection areas. So we're working on two programs simultaneously. One, to define areas that make sense in terms of both hydrology, geology, sub-basin areas, but also similar land uses. So we're not going to combine the alluvial fan vineyards over here with the lettuce, on the sand in the valley floor. More identifying those more unique and similar areas. And then for those areas, very similar to what the Central Valley is doing, is collectively determining what the nitrogen discharge is there based on their irrigation nutrient management data and some modeling likely. And then the groundwater trends program is also going to need to be designed spatially and temporally so that those two things can inform each other. And that will be the ultimate measuring stick. How's the groundwater doing? Are we improving? You know, over what time scale can we detect that? So those two elements will work together as the feedback mechanism. And the program for the groundwater protection area definitions and nitrogen discharge evaluations also includes a series of targets that they need to meet and consequences, feedback loop. I don't want to say consequences, a feedback loop of, you know, additional education, management practice implementation, maybe additional wells need to be developed so that we can get more information in certain areas. So those two programs together are designed to provide that exact feedback loop.
Thanks for clarifying that.
Thanks for asking.
Great. Thanks again, Mary. Next up, we're going to hear from our Central Valley Regional Water Board folks. We'll start with Sue McConnell and the ILRP program, and then be followed up by Hannah Daly to talk about CV salts. Sue, I believe, hopefully your
Do you want me to
connection's-
share, or are you going to be? Thank you.
Yeah.
So, good afternoon, everyone. I'm Sue McConnell, and I manage the Central Valley's Irrigated Lands program. I want to thank you for inviting me to be part of the discussion today, and it's really great to see so many familiar faces and names. Next slide, please. Today, I'm going to provide just a very brief overview of the program and focus my discussion on the groundwater monitoring efforts. That includes the Agricultural Coalition's groundwater quality trend monitoring program, as well as the growers on-farm drinking water well monitoring program. Be happy to talk about other elements of the Irrigated Lands program, some of which Thomas referred to earlier, if you invite me back for a longer than 10 minutes discussion. So I'm really just going to focus on the groundwater monitoring efforts. Next slide, please. So the Central Valley Water Board's Irrigated Lands program, our goal is to ensure that discharges from commercial irrigated lands do not impact beneficial uses. We contain about 75% of the state's irrigated agricultural lands, which translates to about 6 million acres. Activities on those lands are regulated by 9 general waste discharge requirements, and the growers are assisted by 14 agricultural water quality coalitions. Next slide, please. So the growers are ultimately responsible for compliance by obtaining coverage and complying with the waste discharge requirements, by implementing management practices that are protective of water quality, and preparing plans and developing reports on the practices which are submitted to the coalitions, who then compile the information for submittal to the Central Valley Water Board. Next slide, please. The coalitions represent the growers. They help the growers understand how to comply with the waste discharge requirements, and they act as intermediaries between the growers and the Central Valley Water Board. And one of their responsibilities is conducting regional monitoring, including the groundwater quality trend monitoring effort, which we'll talk about more in the next slide. So next slide, please. The groundwater quality trend monitoring is a long-term trend monitoring effort to evaluate the potential impacts of irrigated lands on groundwater. The coalitions have developed networks that have been approved by the Central Valley Water Board's executive officer. They use primarily shallow wells. The coalitions have developed quality QAPPs, quality assurance project plans, which have been reviewed by the QA officer and approved. The data from the groundwater quality monitoring is entered in a GeoTracker and available to the public. Next slide, please. So here is what is monitored through the trend monitoring effort: annually nitrate, pH, dissolved oxygen, and temperature are monitored. And then every 5 years, TDS and general minerals are also monitored. Next slide, please. So here's just a summary of the data that's been collected and available on GeoTracker. About 1,800 samples have been collected at about 500 wells. 30% of the wells have had samples that have exceeded the drinking water standard for nitrate. The coalitions are responsible for notifying the users of the wells of the exceedances and informing them of the health risks associated with the exceedances, and notification happens at 100% of the time when there are exceedances. Next slide, please. So I was asked to talk a little bit about the challenges and the opportunities for improvement associated with the groundwater quality trend monitoring effort. I would start with just the network completion and adjustment. We allow coalitions to use their member wells as a part of the trend monitoring effort, their member wells and other existing wells to just balance the cost of the effort. And some of the coalitions have had challenges with changes to the availability of some of the domestic wells because folks who volunteered to be part of the network have changed their minds. Some of the wells have dried up. There have been wells have been damaged, so they're unavailable for monitoring. And so we've had problems with having to have changes and find new wells. So that's been a challenge for us. Another thing that actually Thomas referred to earlier, just at the water boards, we've had a lot of internal discussions. We've also had lots of discussions with the coalitions about adequate well network density for assessing the large region that we have with the really diverse land use and hydrogeology, you know, for the Central Valley. And we continue to have we're continuing to assess, you know, what's truly adequate for this long-term effort. And then, you know, in terms of opportunities, some of our coalitions are working closely with GSAs to use wells that they're installing as part of their groundwater trend monitoring effort. And so I think, you know, to the extent that they're able to coordinate with other groundwater efforts, that makes a lot of sense. And we're definitely encouraging coalitions to do that. And I really appreciated what Mary said about working with GeoTracker. And I'm going to talk more about how great GeoTracker staff have been in terms of coordinating with us. But that's much more of an issue for the on-farm drinking water well monitoring effort, which I'll talk about next, I think. Next slide, please. So the other groundwater monitoring effort in our program is the on-farm drinking water well monitoring that was added by the State Water Board during the a petition process. With the intent of identifying drinking water wells that are used for drinking or cooking, which have nitrate concentrations above the drinking water standard, and informing users of those wells of the health risks associated with drinking that water. So this is a requirement for all drinking water wells on irrigated lands in rural parcels. Growers are responsible for conducting the sampling. We have developed outreach information with information on proper sampling protocol, but there isn't formal, you know, QA associated with the sampling process. What's required is monitoring for nitrate plus nitrite as nitrogen. And the frequency of the monitoring is dependent on the monitoring result, with a maximum requirement of monitoring annually. So next slide, please. The on-farm drinking water well monitoring effort started in 2019. It was phased in, prioritizing areas with the highest, historic concentrations, nitrate concentration. So it actually generally moved from south to north. It is now required for all wells on irrigated lands and rural parcels within the region. That happened last year, so in 2022. Every well within our program was required to monitor. There is, because it started down south first, there's more data in the southern portion of our region than the northern portion. Next slide, please. So this is an example of what the data looks like on GeoTracker. There is quite a bit of data. The red dots are the wells that exceeded the drinking water standard. Next slide, please. So here's a summary of the data from the on-farm drinking water well monitoring program. We have about, I think slightly more than 20,000 samples collected in GeoTracker. That's from about 13,000 wells. About 32% of those wells have exceeded the drinking water standard for nitrate. We have about 99% of those exceedances. We have documentation of notification of the users. That's a super high priority for us, making sure that we document that all of the users have been notified that there are exceedances when that occurs within the drinking water wells. Next slide, please. So in terms of challenges and opportunities, I want to just echo some of the things that Mary said about batch loading, getting data into GeoTracker as easily as possible from the labs, and then having it be as transparent as possible. I didn't put it in my bullets, but I know that GeoTracker staff have been really great working with our folks in getting some of the improvements completed, and I just want to applaud them for their work and really encourage them to continue to do that good work. Other challenges include the fact that, the growers who are conducting this monitoring, this is really different than all the other monitoring that gets done within our program in the Central Valley Water Board, in that it's the growers who are conducting this monitoring versus the coalitions, right? With the consultants who have ample experience collecting samples. These are folks who this might be the only sample they collect to bring to labs. But another, I guess, challenge and opportunity is that nitrate plus nitrite is the only, those are the, they're not the only constituents of concern in groundwater, as Thomas mentioned earlier, but they are the only constituents that are being monitored. Within the irrigated lands program, there is work being done within CV Salts to expand that monitoring, right? And I appreciate the support that we're getting from the Division of Financial Assistance to help with the management zones to expand the monitoring. Maybe Hannah and Sarah will talk more about that in their presentations. The other challenge is that the monitoring right now, it's only required on irrigated lands and rural parcels. When I talked to the growers about this on-farm drinking water well monitoring program and the fact that the State Board, really want them to know what's in their drinking water. I mean, the question I get asked a lot is, what about my neighbors who live across the street, in these rural areas? They're not required to monitor. Anyways, so that's a challenge. And I know through CV Salts, within the management zones, there is a program that opens up and pays for monitoring for folks within the management zone. So we've been using that as a challenge and an opportunity, I guess. So all this talk about CV Salts, that's what I have, and I'm going to turn it over to my colleague, Hannah Daly, with our CV Salts program to talk more about that. And if you have any questions for me, by all means, you can ask now or drop me an email.
Yeah, why don't we, we'll let Hannah talk and then let's take questions for both of you. Thanks so much, Sue.
Perfect.
Let me stop sharing and let Hannah take over.
All righty. Let's see here. Okay. Hopefully you can see the presentation and not the other view.
I can see the other view, or it's
Yeah,
kind of regular view.
how about that?
Still the same. Go down to the right-hand corner and on your current screen, yeah, and click the. Oh, nothing changed.
Let's do this.
It's still the other view, Anna. I don't,
Still.
yeah.
Let's see.
Perfect.
There you go.
Awesome. Sorry about that. Some technical difficulties. Well, good afternoon. Thank you for having me. My name is Hannah Daly, and I'm an engineering geologist in the Salinity and Basin Planning Unit with the Central Valley Water Board. And today I'll be discussing the CV Salts program and associated groundwater monitoring efforts. So for this talk, I'll provide a brief overview of the CV Salts program, discuss monitoring requirements, and then close with challenges and opportunities for improvements related to CV Salts monitoring. So up first, what is CV Salts? So widespread salinity and nitrate issues in the Central Valley led to the beginning of the Central Valley Salinity Alternatives for Long-Term Sustainability, or CV Salts program. This collaborative stakeholder group is made up of many diverse representatives. Early work was used to develop a salt and nitrate management plan, which was the basis of the 2018 Salt and Nitrate Control Program Basin Plan Amendment. This diagram on your screen provides a high-level overview of the two distinct programs that make up CV Salts. So on the left-hand side of your screen, we have the Nitrate Control Program, which is a prioritized program that addresses nitrate pollution in groundwater by first focusing on areas in the valley that are most critically impacted. On the right-hand side of your screen, we have the Salt Control Program, which is a phased program designed to address salinity impacts to both surface and groundwater. In both programs, permittees have the option to choose one of two permitting pathways. Implementation of the Nitrate Control Program began in the most critically nitrate impacted groundwater basins and subbasins. These are known as Priority 1 basins and are denoted in red on this map on the right. These basins consist of the Modesto, Turlock, Chowchilla, Kings, Cahuilla, and Tule basins. Implementation in the Priority 1 basins began in May of 2020. Implementation in the Priority 2 basins, which are this yellowish gold color, will begin later this year. And these basins are the Yolo, Eastern San Joaquin, Delta Mendota, Merced, Madera, Tulare Lake, West Side, and Poso basins. Permittees who have received a nitrate control program notice to comply must elect one of two permitting approaches or pathways. The individual permitting approach, pathway A, has more stringent requirements and is most feasible for dischargers with low nitrate discharges or those who've already completed upgrades to their facility, like installing denitrification, Otherwise, a permittee in pathway A could be looking at fulfilling all the requirements of the nitrate control program, which at a minimum may include well testing and replacement drinking water by themselves. The other pathway, pathway B, takes a collaborative, locally led approach with the creation of management zones. The management zone participants work together to develop strategies for outreach to impacted communities, provide replacement drinking water, while also developing implementation plans to meet the longer-term objectives of the program. Rather than a prioritized sub-basin or basin approach, the salt control program is Central Valley wide in scale and will be implemented in 3 phases of approximately 10 to 15 years each. Phase 1 consists of the prioritization and optimization study, or the P&O study, which is to define salt-sensitive areas, identify salt sources and impacts, assess management options, and develop a long-term management strategy that can be supported by project development in Phase 2 and then implemented in Phase 3. Like the nitrate control program, the salt control program has 2 compliance pathways. Option 1 is the conservative pathway, which has stringent salinity requirements, and option 2 is the alternative approach, which allows for existing monitoring and control activities to continue, but permittees that elect for option 2 must fund and participate in the prioritization and optimization study. So with that brief kind of overview to the CV Salts program, we'll next talk about the surveillance and monitoring program. So the monitoring component of the CV Salts program is performed under the surveillance and monitoring program, or the SAMP. The SAMP is established through the salt and nitrate control programs for both surface and groundwater to support implementation. The goals are to assess the progress of control program implementation, develop representative ambient water quality conditions, perform trend analyses, and to maximize the use of existing monitoring programs to avoid duplication of efforts. Existing monitoring programs utilized in the SAMP related to groundwater are the Irrigated Lands Regulatory Program, SGMA, GAMA, among many others. The requirements of the SAMP are for the lead entity to gather, consolidate, and evaluate the monitoring data. The Central Valley Water Board has recognized the Central Valley Salinity Coalition as the lead entity responsible for implementation of the SAMP. As the lead entity, the Salinity Coalition will lead the preparation of the SAMP work plan and the Quality Assurance Project Plan, or QAP, as well as ensure that administration of the SAMP and required deliverables are submitted per scheduled requirements and coordinated with other monitoring programs. Reporting for the SAMP will begin in 2026. So the geographic coverage of the SAMP currently focuses on groundwater basins containing the alluvial aquifer within the Central Valley. The alluvial aquifer will be divided into 2 zones, the upper zone and the lower zone. These zones will be delineated by well construction information, depth to water measurements, and whether or not the Corcoran clay is present. Monitoring reporting requirements will range from quarterly to annual, and this will be based on the source program requirements, and will gather data for total dissolved solids and or electrical conductivity where available, as well as nitrate as nitrogen. Other constituents could be added for future analysis, and some of these additional constituents are monitored by the programs that the SAMP will be drawing from. Data obtained or gathered from the representative monitoring programs will be stored and managed in the SAMP data management system, which will be built from existing databases such as CEDAN and the Central Valley Groundwater Monitoring Collaborative Data Management System. The data that will be entered into the SAMP data management system will be obtained from publicly available data that is currently available in GeoTracker and GAMA. The wells utilized in the SAMP went through a selection process to ensure that assessment could be performed at multiple scales for salinity and nitrate. The selected wells will be utilized in 3 different ways. The first of which is for an ambient wells analysis, where an assessment of current groundwater quality will be performed. For this, the depth zone of the well must be known, and there must be at least one post-2010 measurement. Wells selected may also be used for the trend analysis, which will define and assess changes in groundwater quality in one of 4 analyses. Wells used for the trend analysis will be subject to the same criteria as the ambient wells analysis. However, additional filtering of the wells selected will be based on the type of trend analysis that is being performed. So such as a long-term trend or a short-term trend analysis versus trend reversals or seasonal trends. Wells utilized in the trend analysis will also need to have a historical record extending at least 20 years where the data should meet stringent quality control standards. Finally, the wells selected for the SAMP may also be used in the formal SAMP representative trend analysis. This analysis has the most stringent well selection requirements, where the wells will need to represent a specific beneficial use, have been vetted through GAMA or the Irrigated Lands Regulatory Program groundwater trend networks. They must also have a known completion and be spatially unbiased through using a distance-weighted criteria depending upon water quality. For those first 2 analyses, approximately 22,000 wells meet the criteria to be potentially used for this analysis. So those first 2 analyses are really focused on having a data-rich, lots of wells to choose from. For this 3rd analysis, approximately 600 wells meet the criteria to be used. And this network, this analysis, is really driven by accuracy and consistency to be able to understand the impact of implementation of both the salt and nitrate control programs. So this slide has some figures that show the geographic extent of the SAMP. The extent of the Central Valley alluvial aquifer in that lightish blue, and each point corresponds to the wells that have been currently selected for the representative trend monitoring, that 3rd category with the more stringent standards. On the left, we have wells that were selected to be monitored in the upper zone, and on the right, we have the wells that have been selected for monitoring in the lower zone. Again, these wells were selected to be spatially distributed across a basin, but also to incorporate an element of randomization to reduce bias associated with specific land use types. So in terms of monitoring challenge, remember SAMP implementation will not begin until 2026. So this is a list of some challenges we've faced and encountered thus far. Some challenges related to data are really trying to match thousands of data points to multiple potential wells within 1 square mile sections. Also, the consistency of analytes reported to GeoTracker, especially with self-reported data, and then the alignment of reporting frequencies between monitoring programs. In terms of working with the public, it has been a bit challenging trying to work with well owners to determine when and if replacement water is needed, and trying to respect the privacy concerns of landowners and tenants. The largest opportunity for improvement for the SAMP is going to be the spatial coverage of the representative trend monitoring. The network for this analysis is dynamic, and the initial selection of monitoring locations were to maximize the use of existing monitoring programs and selecting wells that are not only publicly available, but also accurate. As implementation continues and salinity and nitrate reduction projects are implemented, additional monitoring locations may be incorporated into the network, and the monitoring network may be revised to ensure sufficient coverage across the Central Valley. Also, the original reporting requirements for the SAMP did not align with the Irrigated Lands Regulatory Program reporting requirements, and the regional board was able to coordinate with the Central Valley Salinity Coalition to resolve this issue, and were able to identify the inconsistencies in the timeline and ensure that reporting requirements and timelines were consistent and not duplicative. And with that, thank you for giving me the opportunity to discuss CV salts. And are there any questions?
Thanks, Hannah and Sue. Are there any questions for Region 5 staff? Okay, Peter.
I was just curious about a lot of the the farming communities in these areas. Is there widespread support not only for what you were just talking about, but also in some of the previous presentations, or is there fear from the farming communities about some of these new requirements and that sort of thing?
I would say the most consistent feedback I've gotten, Peter, is the concern about the costs. Fees have been going up, and every additional requirement increases the amount they have to pay, right? So now they're paying for the Irrigated Lands program, the coalition to help them with compliance, and now there are additional fees associated with these management zones. That's the biggest concern I've heard. I don't know, Hannah, have you, and Sarah's here as well, so I know you talk to the growers directly, even more than I do.
I think as far as the CV salts requirements go, I've seen the ag coalitions, their growers, and the dairy industry be our probably biggest champions and supporters, both financially and in supporting the cause and the mission that we are embarked on. When it comes to management practices, I think the constraints are what most of us would assume, and those are technology and water availability, and really getting at where maybe some marginalized farmland is part of irrigated ag, and maybe taking things a little more holistically. And that's where partnering with Sigma and GSAs comes into play.
All right, thank you.
I saw a question from Mark, or a hand from Mark. Did you bring it down because we're behind schedule, or do you have a question?
I did bring it down because we're behind schedule, but
Okay,
I could ask it out loud.
Yeah, yeah. Once you ask it out loud, like worst case, we'll run a little bit behind. But
well, this is a question for Thomas, actually. Having seen these 3 presentations representing large data sets being collected, but these data are of various qualities and the identifying the quality is really variable, and so it's maybe very hard to use for other purposes than just to recognize where the problems are, or who needs to be informed of drinking water quality problems or whatever. But are there opportunities to take, just because there's so much data, to use it for other purposes, like validating models, or further characterization of groundwater, or predicting where we might be looking for hotspots or other issues like that? So kind of a nebulous question.
I'm going to get at a little bit of that in a minute, Mark.
Okay, yeah.
For the Central Valley, at least.
Yeah,
but go ahead, Dr. Harder.
Although he might not still be here.
Yeah, he might not be. Let's put it.
Sorry.
He's here.
Yeah, just very quickly. Yes, the fact that the data are actually available online is hugely helpful, and we are using those data, for example, to validate a Central Valley nitrate modeling toolbox that we're developing, just as one example of where these data become hugely important. And we've used these data in the past to look at questions extensively on the relationship between nitrate and land use. And others are doing that as well.
Great.
Okay, and then Sarah can follow up.
Yeah,
Thank you.
Thanks.
Thanks,
Mark.
Thomas.
All right, with that, we'll turn it over to Sarah. Thanks so much.
Everybody. I'm Sarah Rutherford. I apologize, I didn't proofread our agenda. I don't represent an ag coalition per se. I represent a management zone, which which we've named the Kauai Water Foundation. And we are one of those management zones that Hannah was just telling us about. And so actually, Nick, we can save some time. I had an intro, not sure what Hannah was going to cover, so we can probably skip to slide 10 or 11 because Hannah already covered all of this for us. We even use the same charts. That's how long we've been doing these things. Go ahead, keep going. So this is what she talked about. And so I'll start kind of with our local area and how we've taken on the challenge of implementing the CV salts nitrate control program. And really, I think the most interesting thing for this group is what we're looking at in the next 6 months. I hope you can invite me to come back next year or even in the winter to talk about what I'll briefly describe here today, but everything's in draft. And so I can't show you the really cool, exciting stuff that our consultants are doing for us, but I can give you a little preview. So the Kauai Water Foundation is in the northern portion of Tulare County. If you are familiar with nitrate and groundwater contamination, this is one of the most impacted areas in the Central Valley. We cover a number of disadvantaged communities of Tuleville and Tonyville, which are somewhat incorporated, but their resources are severely strained both for water quality and water quantity. Our larger municipalities include Tulare and Visalia, and their wells after treatment, and most of the communities in our area meet the drinking water standard for nitrate. But as you have heard, a lot of our domestic well users do not meet the drinking water standard for nitrate. Next. So how are we organized? We are a nonprofit 501c3. We are federally recognized, and we formed about 3 years ago. And for an example of how management zones figured out how to get at this is we've got our board of directors. I am their executive director, and we have various program managers that I work with. We have an advisory committee stakeholder group. It's very diverse, made up of about 20 community leaders. And then we also work with a number of sub-consultants, geotechnical, marketing, web development, and all of those things to get this message out there. Next. So we talked a little bit about irrigated land so far, and Hannah discussed that there's lots of different dischargers of nitrate that received that notice to comply. What a management zone is tasked with in part is bringing together all of those different types of discharges, which I've kind of summarized here as industrial and food processors, wastewater to land, your municipal wastewater treatment facilities, dairy and bovine operating facilities, and then in our case, the Irrigated Lands Program, the Kauai Basin Water Quality Association. The construct under CV salts is that a management zone, and those who went that pathway B that Hannah talked about, looks holistically at managing nitrate, both short-term and long-term, to provide drinking water solutions, and they work collectively together to improve water quality. Next. I should mention on that slide, all of those participants contribute financially to the nonprofit. It's the bulk of our funding source. Actually, it's 100% right now. And I'll talk about safer funding in a moment. But that is how the program is run and operated. So what is it that we're doing? Next slide. So I told you about 3 years ago, we got started, and in March of 2021, we submitted our first look and proposal of how we're organized, who we are as an entity, who's participating, and then a pretty technical analysis of hydrologic conditions and what we've determined to be the upper zone. That is nuanced in how it's defined, but I think for the purposes of this group, it's say plus or minus maybe 30 feet to your first encounter groundwater. So we're looking at really where we would expect domestic wells to be drilled to within the aquifer. We also, about 3 years ago, looked at data gaps. We looked at impacted water systems. We looked at groundwater elevation and flow, and really tried to look again holistically at the landscape and what is known at that time. So next. So this is an old figure from from when we first did this. Again, we pulled this data about 3 years ago. As Sue described, there's far more data available now through the Irrigated Lands On-Farm Drinking Water Program. And I'll talk more in a minute. We do our own testing as well as a management zone. And so here you can see where we thought there was wells that were at that screened interval of upper zone. And you can see the red exceed the nitrate standard, drinking water standard. Yellow is 7.5 to 10. And then green would be those 7.5 and below. And from this and a few other publicly available data sources, we can go to the next slide. With the use of kriging and interpolation, this is an estimate of where we think nitrate concentrations lie within the entirety of the aquifer. So this extrapolates beyond just that upper zone. We do have data gaps, at least in our area in the southwest portion, that don't paint a whole picture. So this map is, I would say, not as holistic as what we're getting ready to go do, but it gives you an idea. And what you see in our area, at least, is where we have surface water recharge. Those are those darker green areas in the middle where it forks out kind of in the center there. We do see a benefit to reduce concentrations of nitrate, but you can also see that there's maybe not so much correlation with the other areas that you can also see are largely red. I'll add that in the past couple of years, what we've learned too, and Dr. Harder referred to this as well, is just because that area is illustrated in this graphic is red, that does not mean that every well, especially the domestic wells, exceed the drinking water standard. We frequently see domestic wells where one neighbor exceeds, one neighbor is way over, one neighbor is less, and so it really is case by case. And, you know, to Mark's question about landscape management and the potential influences there, I think it's very nuanced. We have a lot more work to do. What this program doesn't necessarily get at is tracking a molecule of nitrate and where it came from. That is not our objective. Our objective is to manage all sources of nitrate to holistically improve the aquifer. So we can go to the next slide, please. So what are we working on that I'm telling you is very exciting? Well, we're doing something that probably hasn't been done. Dr. Harder showed some illustrations earlier. We are using data that's submitted to the water boards. We're using information from each permittees on a one-by-one basis. We've conducted interviews. We've collected at a granular level where nitrate is being loaded into the system. And we are doing that again in a holistic way from both point and non-point sources. And we're creating methodologies to establish a baseline of where we're currently at in terms of nitrate loading. We also are looking at areas of impact. So where we know there's impacts, where it's been documented, say to a public water system, things like that, but also looking into the future, long-term planning and potential impacts in the future to water systems and domestic well users. And then most importantly, a nitrate reduction plan over the next 35 years, how to reduce the impact of nitrate in the aquifer and fate and transport throughout the whole system. And that's, again, we're partnering with GSAs is really critical for aquifer recharge, for reduction in pumping, and also just land use management. Next, please. So while we're busy doing this technical component and long-term planning, we also are tasked with providing clean drinking water right now. And so we call that our early action plan, our EAP. We reach out to community and impacted residents, which, as I just described, could be almost anybody who has a domestic well. So we're at community events. We send out flyers and mailers. We work with community leaders. We coordinate with other community organizations and really just try at a grassroots level to connect with families in our community who don't know if their water is safe to drink for nitrate. Next slide, please. So this slide kind of shows the progression from immediate solutions, point of use systems, drinking water, bottle filling stations. I'll describe bottled water delivery. Once we test a well and we know that it exceeds the drinking water standard for nitrate, And then on our long-term solutions, maybe those look like things such as systems consolidations, improved treatment, or new wells. So next. And so this is kind of the holistic picture. And I wanted to highlight here how I've described our public awareness and education campaigns, our replacement water, our bottled water, our options for clean drinking water in the near-term, short-term future. And then in the middle there, our domestic well testing. And so this is really important. We offer free domestic well testing to anyone in our area that is not connected to a public water system that's compliant for nitrate. We go and test for nitrate and we get the result back to the user themselves. It's only for nitrate. And so that does make using point of use systems prohibitive because we would only be able to treat for that one potential contaminant. And so this is where management zones have been working closely with Division of Financial Assistance staff at State Water Board, who have been really diligent in helping us to secure safer funds so that in the near future, and some management zones too are already doing this, testing for additional co-contaminants. And so that provides the user a more holistic understanding of what's within their domestic well. And so those include some of the things that Dr. Harder described, TCP, DBCP, and also naturally occurring contaminants, alpha particles, and arsenic, things like that. So with additional funding from the state, and there's match included in that from the management zones and covering 100% of anything regarded to nitrate, the management zones are expanding their programs beyond what was required under CV salts to provide communities a more holistic approach to clean drinking water. And that's because we're already out there doing the things illustrated here. And so from our well testing program, again, Sue described some of that. That data will eventually go into GAMA and GeoTracker. We're working again with staff to figure out how to provide unique identifiers for this program. It's quite a challenge because GeoTracker is designed for a point source reporting system, kind of like how Dr. Harder was describing our Superfund sites. That's kind of how GeoTracker was initially set up. And so you heard how Region 3 is kind of trying to figure it out. We're trying to figure it out too, but the data is all available. We have shared it and it will be publicly accessible as soon as we're able to work with staff on that. But from that, in our other assessments, we do pull from other data sources as well. And so there's very much an exchange between the programs to connect all of those various data sources. Next, please. This is just, I'll kind of skip this. We actually just this week crossed over 200 households receiving bottled water delivered direct to their door. And we also provide this option of a free drinking water fill station where there's no registration required, no testing required. Anyone can show up and take as much water as they'd like. And that's part of our current solution set. So I believe that's about it. If you want to go to the next slide. Yeah, so that's it from me. And I can take any questions.
Thanks, Sarah. And sorry about the misnomer.
No, I should have looked.
My fault. I
No, my
confused
fault.
about the whole thing. Anybody got questions for Sarah? Let me check the chat. Well, thanks again. It sounds like great work. I'm always excited to hear about free well testing for folks that are not connected. So this is all great information for me. So next up, we have Kezia Rivers from the Community Water Center. Kezia, are you ready?
Yeah, I am. Thank you.
Great.
It's pronounced like Kaya.
Oh, sorry.
No worries.
Kaya. Thank you. There we go.
So thank you for having me. It was nice listening in on all of the presentations before me and the ones that come after me. But hi, everyone. I'm Kaya Rivers. I'm a policy advocate at Community Water Center. And I'm hoping to shed some light on how contamination disproportionately impacts small disadvantaged communities and how current water quality monitoring and testing fails to capture the full picture of water quality impacts in disadvantaged communities. Next slide, please. So our mission at Community Water Center is to act as a catalyst for community water solutions through organizing, education, and advocacy in California. We work to ensure that all Californians have access to safe, clean, and affordable drinking water. Next slide, please. So over 1 million people are impacted by unsafe water each year, and up to another 11.8 million people are being served water from wells where increasing trends suggest that concentrations could exceed MCLs and require treatment in the future. And we primarily work in the San Joaquin Valley and the Central Coast, and first started organizing around nitrate. Now 123, TCP, arsenic, and other contaminants are also significant issues. And often residents have multiple contaminants found inside of their drinking water. And we know that these challenges disproportionately impact low-income and Latino communities, with people relying on private wells are significantly impacted due to not knowing if their water is safe to drink, since they're in charge of their own water quality testing. And even if contamination is found, the options for treatment may be limited, and costs for treatment can also be prohibitive and expensive at times. Next slide, please. So our work is really on working alongside community partners to implement the human right to water law in California, which states that every human being has the right to safe, clean, affordable, and accessible water adequate for human consumption, cooking, and sanitary purposes. We and many other groups worked to pass the Human Right to Water Act in 2012, which avoids perpetuating the idea of second-class water, as water is a basic human right. And without adequate implementation of existing nitrate regulatory programs and well testing and monitoring, upholding the human right to water grows to become increasingly more difficult to accomplish. Next slide, please. So unsafe tap water can be found in nearly every county of the state, but areas like San Joaquin Valley and the Salinas Valley are disproportionately impacted. Many small rural communities rely solely on groundwater for their drinking water, which when contaminated can cause major health concerns. Contaminated groundwater is primarily the result of intensive agriculture and industrial activities, such as the application of fertilizers and pesticides, large-scale animal feed operations, and mining. However, some contaminants are also the result of naturally occurring processes in the groundwater as well. And as we know, contaminants found in water supply are nitrates, arsenic, coliform bacteria, uranium, 123 TCP, Chrome-6, and PFAS. Next slide. And GAMA is a great tool which provides many data points on groundwater quality impacts, in addition to some of the tools that were mentioned earlier today and the data that's gathered. However, the available data points don't paint the full picture of community impacts. It's the best tool that we have, yet it's not quite enough. Data points are refreshing at different times due to monitoring schedules and constituents tested and overall age of the data. And even though it utilizes well testing and monitoring information from different agencies, organizations, and programs, recent well quality data is limited, especially for individual domestic wells. Monitoring is sparse and uneven across domestic well communities, which is a concern because domestic well owners are usually not testing water quality themselves for all contaminants. And this image depicts the nitrate contamination well data that we have from domestic and municipal wells from the last 3 years, including wells that are out of compliance. And there are many data points. However, there are many wells nearby these data points that we do not know of and are out of compliance as well. And this is just for one contaminant. And management decisions are being made without fully understanding the scope of the problem. Next slide, please. With that being said, groundwater recharge, when done irresponsibly, can worsen already existing water quality issues or can create areas with new water quality issues. Snowmelt and recent storms present an opportunity to replenish groundwater levels, but groundwater recharge must be done with disadvantaged communities' drinking water needs at the forefront. Adequate mapping must be done in order to determine where to best locate recharge projects to provide both benefits to nearby disadvantaged communities, but also to avoid further groundwater quality degradation. Additionally, groundwater quality changes must also be tracked on both recharge sites and near disadvantaged communities to track changes in groundwater quality. Next slide, please. So CWC serves as a technical assistance provider for West Goshen, which is a community in Visalia, where this community has both water contamination and dry wells. Nitrate, 123 TCP, and arsenic have all been identified in 12 wells with concentrations over the MCL. And West Goshen is not the only community that experiences drinking water contamination. Wells tested in communities throughout the Central Valley have nitrate as high as 3 times or 4 times the MCL. And without adequate well testing and monitoring, many communities don't know if their water is safe to drink, leaving families' health at risk. Next slide, please. So there's a couple of programs that can identify water quality in domestic wells, one being CV salts, which we already heard about today. But CV salts, if implemented successfully, can make improvements in domestic well testing and overall progress in securing the human right to water. Under CV salts, management zones are tasked to implement early action plans to identify nitrate impacted residents and provide replacement water to impacted households. And since the program started in about 2021, only 16% out of the 13,000 estimated nitrate impacted wells have been identified. And our best estimates show that over 10,000 people may be drinking nitrate contaminated water unknowingly in the regions where the current 5 management zones operate. These are supposed to be early action plans, yet majority of the residents who may be drinking nitrate contaminated water are still drinking unsafe water. And CWC works to spread awareness about the services that management zones provide in order to support residents who want to receive well testing and bottled water. However, it is important that management zones improve their outreach methods to identify potentially impacted residents as soon as possible. Next slide, please. So water quality concerns are also prevalent on the Central Coast, where many disadvantaged communities endure drinking water contamination in Pajaro, the Salinas Valley. Similarly, in the Central Valley, many residents don't know that their water may be unsafe to drink due to limited water quality monitoring around vulnerable communities. And community leaders on the Central Coast that we work alongside have levels of nitrate in their drinking water over 4 to 5 times the MCL. And families on the Central Coast also endure seawater intrusion, making the water produced from their wells undrinkable, ultimately adding another layer of drinking water scarcity. Next slide, please. The Irrigated Lands Regulatory Program conducts on-farm domestic well testing both on the Central Coast and in the Central Valley. And we're concerned that the domestic wells around the surrounding areas will be put at risk as nitrate concentrations vary widely from well to well. Within third-party groups, larger townships reach compliance and nitrate reductions as a group, and this aggregated data can also leave vulnerable wells at risk, as people don't drink an average and families rely on individual wells, which may be at risk for contamination. Next slide, please. So to conclude, the current state of nitrate contamination and the overall drinking water contamination is concerning. Contamination will only increase the longer growers stall to reduce their nitrate loading, and the current well testing and monitoring isn't quite there yet to fully address the impacts to vulnerable populations. Communities in the Central Valley and on the Central Coast are disproportionately impacted by groundwater contamination. And groundwater basins will unfortunately be contaminated for decades. And we need ongoing contamination to end now and to earnestly test and monitor domestic wells, especially in disadvantaged communities, to mitigate the impacts. Next slide, please. Thank you for having me again. And I'm open to take any questions if there are.
Thanks, Gaia. Any questions? Oh, and there's an applause emoji. The thing in the chat, but thanks for the great work you guys are doing. Appreciate it. And thanks for coming and presenting for us. We really appreciate it. With that, we'll turn it over to Dory Bellin from the Division of Water Quality and the GAMA Groundwater team.
Thank you, Nick.
Let me stop sharing. There we go.
No, we're a tiny bit behind, so I will.
No worries. Yours is probably the prime time. I'm sure this will be a lot of interest. So.
Okay, great. I'll do my best and drive us at the same time. Okay, so as Nick said, thank you guys. Thank you for everyone that's spoken before me. I'm representing the GAMA program, stands for Groundwater Ambient Monitoring and Assessment. My name is Dory Bellin. I'm a geologist with the program, and I'm here today to talk about what GAMA is, what we're producing, how we use the data, and future work and outreach. So we will go over just a little bit of the overview of the program, what our GAMA GIS is, how we're producing online tools, and how ways people can participate. So very quickly, I'll just go over why we started GAMA. We started GAMA because around 2000, 2001, because people were concerned about MTBE, and all of a sudden the legislature realized we had groundwater. So we got some funding at the time. We developed a program and started working on an early program. It was actually called the California Aquifer Susceptibility Program in 2000, when the Budget Act gave us our first directive at the Water Board. So early GAMA was actually a good starting point for our cooperation with USGS and Lawrence Livermore Labs. And then we further expanded into what we are today by Assembly Bill 599. That was the California Groundwater Monitoring Act of 2001. And out of that was mainly our requirement to produce a statewide comprehensive groundwater monitoring program. We call that the Party Basin Project, and I'll be going into that very briefly. Our main two goals, legislatively mandated, were to improve the statewide comprehensive groundwater monitoring and then make this information readily available to the public. And of course, by doing and reaching those goals, we want to actually have a vision of benefiting all of our decision makers to manage our groundwater resource effectively. So our main components of the GAMA program is one, the Priority Basin Project. That is our biggest resource as far as time, as far as funding. And that is what we do with USGS statewide. And that was what is actually concentrated with our mandate from AB 599. But we also have other parts of the project. Domestic Well Project, Special Studies Project, our GAMA Groundwater Information System, which reaches that mandate of making this information accessible to the public, and then providing hydrogeologic technical assistance to anyone within the Water Board and outside. So first, looking at the Party Basin Project, when we first started this in 2003, 2004, a framework was set up by USGS and our report to the legislature, really giving the outlook and the framework for developing this program. The goal was to look at the raw groundwater source used for public supply drinking water sources through the state. So with the help of the USGS, we looked at the state and our Bulletin 118 groundwater basins and comprised and composed different study units, 35 of them across the state. That represents over 95% of the public supply water use in this state. And of course, we applied a trend monitoring program, which would revisit about 20% of the wells every 5 years. So not only is there a baseline statistically unbiased sampling network in each study unit, but we also revisit those study units every 5 years to get a portion of those wells resampled. In 2012, 2013, we completed those 35 study units, and we then switched our directives to look at the shallow aquifer. So that drinking water supply accessed by domestic wells and small system wells. So we looked at the states. USGS delineated groundwater units, and that is our groundwater basins and their upland portions, knowing that our domestic and small systems were actually accessed outside of our groundwater units. So we then composed our study units out of these groundwater units. First, looking at the way that, I guess, the percentage of domestic well use in those groundwater units. We then prioritized those groundwater units and went to those areas first. These are the study units that we have sampled so far. We've got about over 1,000 wells, including the trend wells that we've revisited for these shallow study units, we call them, or those used for domestic and small system supplies. And we have a lot of different products with the Priority Basin Project. One, we are publishing all of our data to the GAMA GIS. It used to be called GeoTracker GAMA. I'm sure a lot of you know it by that name. We didn't like the confusion with the GeoTracker system, so we've got a renaming there. We also publish with the USGS. They publish a lot of different reports, but we have recently switched to a more data release format. It's more modern. It not only publishes all of the data, but it also gives people spatial data as well, and it comes out a little faster than the publications were. Our other product is the GAMA Groundwater Information System. So this is where a lot of people already know about it, but we integrate, display all of the groundwater quality data, not only from the GAMA program, but from other agencies in the state. We standardize all this information so you can query across all of these data sets simultaneously. We offer 83 million different analytical records from approximately 300,000 wells in the state. We also have analytical tools and reporting features that you can use and interactive queries, whether they're for actual looking at the groundwater quality data or actual additional layers that you would like to interact with that data. Our special studies project is somewhat on hiatus, but we are doing a project with Lawrence Livermore and Sac State East Bay. We're actually doing that in conjunction with Sigma right now, and that is to look at well vulnerability in the state. This part of the GAMA program looked into a lot of different special studies, meaning concentrated issues of groundwater in the state. Looked at groundwater age, sources of different contamination like nitrate, wastewater indicator studies, stuff with isotopes and trace elements. And the domestic well project is also on hold. This is where the GAMA staff actually went out and did the sampling county by county. It is constructed differently than the actual Priority Basin Project because there's no grid sampling network here. There's no unbiased sampling. This was survey response. We sent out a brochure. We got responses on who would let us sample their well. Since we are shifted or had shifted already to the shallow aquifer for the Priority Basin Project, we felt that this wasn't necessary to continue at the time. And then I mentioned that we do provide some hydrogeologic technical assistance. This is for GAMA staff at the Water Board. Does provide some assistance to mostly other agencies and divisions within the Water Board, but this has to do with consultations with different recycled water and desal projects, groundwater monitoring, and some GIS analytical work as well. Our program website and the USGS GAMA program website provide a lot of information. At the State Water Board, our website provides a lot of information for private well owners. So information about how to keep your domestic wells safe, where you can get testing, etc. We also have a good set of groundwater chemical of concern information sheets where people can learn about specific chemicals and their prevalence in the state. Some more information about the background of the GAMA program. And then access to all of our online tools and publications. Some newest things are an additional page for the GAMA GIS, where we've started to produce some video tutorials on how to use the system and how to actually work with the data. What does it mean? On the USGS GAMA program website, there's a lot of great resources there as well. They dedicate a lot of their content to how to volunteer for the GAMA program, especially since we're moving to the domestic wells. There are videos there on what to expect as a participating well owner, which is very helpful for people that would like to participate. At this website, they can also select an area knowing where we need a volunteer well, and they can submit their information saying that they are interested to be in that grid. There's also information on their homepage of all of their different web tools and recent studies that have been published. So now I'll go actually into the GAMA Groundwater Information System and get off of this presentation a little bit so you can actually see how to use the system in a brief way. Like I mentioned, the GAMA GIS is a place where we centralize groundwater information. This is pre-treatment across different agencies. At the top there, you can see all the different data sets that we do standardize into the GAMA Groundwater Information System. And we do this so you can have a map interface that allows you to look at all of these agencies' data sets on a map and be able to query how you would customize that query. We then use this data that's produced out of this site for our own use also to make these actual data tools on our website. And I'll show you that page in just a moment. Recently, we have updated the site. We have actually become a little bit more transparent. I know there's been talk about different qualities of data, and I believe Mark mentioned that from different data sets. It does vary across the different data sets. The tables that you can download from our site do produce, and actually will be producing even more source information. So what did that data look like before we standardized it? So you can see a little bit more information about that and some reporting limits, etc. We also have a new data upload. It's called the data connection tool. This is where maybe smaller data sets, we've heard that maybe, for example, region 6 had like a PG&E data set of domestic wells. How do they get that into the system? So now we've created a data connection tool, and I'll be able to show you that in a moment. We also have a lot of layers that we've added to the GAMA GIS. I will show you how to access those. And then there's that data connection tool. So I'm going to switch over to the internet so I can show you guys what I'm speaking of. So this is the GAMA homepage. Here you can find different links within the GAMA program. We have a link here to the online tools, which I'll show you. But you can also go to the projects link here, and you'll see information about the projects that I just spoke of. There's a link here for the GAMA GIS on the right-hand side. And this page kind of goes over how to get to the data connection tool, how to get to the system, and also the beginning of the video tutorials that we'll be producing to put on this site. So there will be some more coming. So one, I would like to show you the actual data connection tool. And this data connection tool, like I said, is a way for people to submit data sets that aren't already standardized into the GAMA GIS. There is a template that you can download, and it basically shows you how to input this information, and also a way to upload that information and the laboratory report that came with it. There's certain standards, requirements that we have for this data. And right now it's set up to where GAMA staff would manually look at this data after it is uploaded. And we're looking into ways to further develop this too in the future. The online tools page brings us to a page of a lot of online tools, which I will show you a few of. So let's go over to the GAMA Groundwater Information System. I'm sure everyone's familiar with the default homepage. When you first get here, you have a box in your lower left-hand corner of how to start your query. You set your actual area, chemicals, time frame of those chemicals, the well categories that you would like to look up. You could also click on advanced data sets. And if you, for instance, want to look at just the ILRP data, you can select that and look at that as well on its own. You can go back and forth, but there are also some other widgets here at the bottom of the screen. There's the layer widget where you can, while you cannot query by these layers, you can overlap them onto your query. So if you wanted to look at, the geologic map, you wanted to look at the oil and gas field boundaries, there's a pretty long list here from different data owners of different layers that you can look at with your query. When you have produced an actual query on your page, you can download that data. I know it's kind of small probably on your screens, but there's different choices here. Download data is your first option. That's looking at all of the water quality data that's currently on your map view. You can download that data and get it into a table. You can download a KML file. You can download just some application data. So you, without the water quality data, you can look at just the locations, so you can get the lat and long, and then any well construction information comes with that as well. We also have our tabular data download. If you click on that, it opens up the GAMA data download page. And on this page, we've provided a lot of different tables, so you can look at each data set, either by county or statewide basis. So if you've noticed on the main map page, you have to select a smaller GIS area. If you want to then look at statewide data, you can do so. So each of these opens a separate menu, and you can look at each data set along or being constrained to the state. We also have some other data sets that you can download, which includes all the PFAS data or the UC Davis nitrate report that Thomas Harder was speaking of, or just all of the well location and construction data. We also have been adding a lot of the new standardization, data dictionary, chemical mapping, ways that the field mapping, that was when I was speaking of being more transparent about the source data that we are publishing and standardizing into our data set. So this is information that you can attain for the metadata and understanding our data more. So I'm going to take you over to the USGS GAMA website. You can reach this easily. It's a pretty simple URL, but you can also just search in Google USGS GAMA, and it will bring you one of the first options there to this URL. So they will go over a little bit of the GAMA program background, but they also have their main tools right on the front here. We've got one on the right. This is looking at all of the data that you can download by study unit. You can look at it by trends versus the baseline sampling. And then this other tool over here is so you can look at the actual trends data, the actual assessment of trends. That was something that Dr. Harder did show a screenshot of. So you can look at the actual trends statistical assessment that was placed on our trends data and learn a lot about the trends of the naturally occurring compounds that we've sampled for. We also have a lot of links to all of the data that you can download, including the reports, the data sets, and the GIS layers. Going back over to the GAMA website for our online tools, the first option here is our GAMA groundwater information system. So that's just another way that you can get to that site. Everything below are tools either the USGS GAMA team or I have made, and they're mostly Esri web applications. They also focus on specific groundwater issues, so we can dive into them more deeply. We've actually provide a resource for different decision makers across the state or domestic well owners to understand something more about their groundwater. For example, let's take a look at one of our, this is the aquifer risk map that is part of SAFER. This is where Emily Houlihan, she has worked very hard, and I've helped her a little bit with the aquifer risk map through the SAFER program. This is just looking at the domestic wells and the state small water systems. This is another Esri-based tool using a different methodology than, obviously what we've used to just get the data onto the system, but this allows you to look at groundwater with a different methodology applied to it. This is the public supply and domestic supply download tool that USGS made, so you can look at all of the different data sets that we have collected and download those with the study units. This is the groundwater age application I created. This is also on the online tools page. So this is just another example of another groundwater issue that we're trying to produce tools for, so you can actually look at that specific issue and not have to process that data yourself. This is looking at that tritium helium dating that we have collected. This was actually straight from the Lawrence Livermore paper that they did, where they interpolated the surface of this data onto the state. Those lighter colors are the younger portion. This is all, of course, the tritium containing portion of groundwater. So this is the younger groundwater. This is where you can actually see areas of natural and artificial recharge. There's a great little widget down here that looks like a bookmark. And this bookmark tool lists all of the managed and natural recharge locations throughout the state. And you can then see that reflected in the data, which is really cool, I think. There's another tool that's on the online tools webpage, and this is we'll refresh the page, is my well near So it's mainly for a domestic well owner. Is my well near impacted groundwater for nitrate and 123 TCP. So there are two separate tools, one for nitrate, one for 123 TCP. This is the one for nitrate. And this is where we've just made available all of the most recent detections of nitrate across the state that are above the MCL. And there are directions. This is actually a story map where people can, especially domestic well owners, is who it started to, they can look for their area. They can either enter in their address or they can zoom right in and they can see based upon where there is existing exceedances, if they are close to known exceedances. This data does need to be uploaded. It hasn't been uploaded or it hasn't been updated in about a year or two. So that's something I need to work on. We also have another somewhat newly released tool. This is the Source Water Protection Data Hub. This is a location of data centralized for both ground and surface water. So what affects our source water? What affects our surface water intakes or groundwater wells? So there's a lot of different information that you can gather from this application. There is a layer list that is not only for groundwater, but also for surface water as well. For example, we not only have sources of contamination like TMDLs, impaired waters, but we also have those that we would only assign to groundwater as well. So the information from the aquifer risk map, known like regulated contamination that we would see on GeoTracker, et cetera. So this is an attempt to really get everybody's data in one place to look at what could affect a source, whether groundwater or surface water. Oh, that's our zoom in. Going back to the actual presentation, I just wanted to make sure that we covered everything. We did go over the different widgets on the groundwater information system. There are additional reports and assessment tools that you can use. You can draw on the map to query only by a drawn boundary that you place on that map. There's some pie charts where you can look at contamination based upon a groundwater basin specifically or other boundary areas. You can measure different distances on the map, etc. So these are all the different tools that I just went over. There is the actual safer risk assessment that was done for the domestic and state smells as well. For the needs assessment, the aquifer risk map. We have the data download tool on the USGS site. The groundwater age tool is my property near a nitrate impacted water well, the same for 123 TCP. And we also have a salt nutrient management web map. This allows users that are following the requirements under SNMP for their groundwater basins to see if that SNMP report has been made. It links you to that report and helps you understand what the boundaries of those SNMPs are, and the source water protection data hub. So we not only can provide all this data, but we're also producing these data tools that we hope are going to be useful to a lot of different audiences, whether you're a decision maker at a water resources agency, if you are a regulator, if you are a domestic well owner. This is the data connection tool that I went over, and that's fairly new for us. But we do all of this in the realm of in the public view. So we do like to make sure that everybody realizes that we are there to answer questions and provide training for any audience. So our outreach efforts do take us, excuse me, traveling across the state to provide that training to anyone that requests it. We also have a lot of resources for the small systems and private domestic well owners. Our outreach has consisted of providing that well testing to those where we're doing those studies at the time, or referring them to the people that would do it for them. And we also have an advisory committee. It's for short called our PAC. I've noted how we went from our first phase of the public supply drinking water groundwater source. We switched over to the shallow used by domestic and small system wells. And now that we've gotten both resources of the groundwater, we really want to make sure we've collected all this data. Now, what do we do with all this data? Now, we have been making some, actual web applications for people to use, but let's look into directing these resources to focus on the drivers that are causing groundwater quality change. So we'll be looking more into the recharge aspect. We have a great tool that was just published by the USGS that looks into the depth to the pre-1950 water. So looking at how groundwater pumping or recharge affects that depth to the older water. So that's a great resource. We want to produce more tools like that, and we'll actually be holding a public PAC meeting the week of June 12th. That's coming up fairly quickly. If you're interested in that, let me know. I'll put you on our mailing list so you're notified of when that public meeting occurs. We also have open communication with our regional boards, our STIGMA, and other agencies. We want to make data tools that work for them. So any suggestions that you guys have, needs that you have for different groundwater issues, we want to make sure we're producing them for you. So please always reach out to GAMA@waterboards.ca.gov or myself personally, and we'll be happy to help you and provide any training as well. Did I do it good and fast for you? So that's the end of my presentation. I can take any questions that you might have.
Super fast, but super informative. Any questions from the audience about all those tools that have been created?
Yeah, and just, you know, if you go to our webpage and you look at our online tools page, there's a giant list of them. So we want to make sure that not only do you have access to them, but for any online tools that you have suggestions for, go ahead and play with all these, you know, but if there's something that we could be addressing a little bit better for you, please let us know.
Yeah, I'd be interested to kind of hear what Krista mentioned, some topics with sea level rise and groundwater rise, as well as kind of the movement of water and mobilization of contaminants, and seeing maybe
Yes,
how
so
these
then,
tools.
yeah, so looking at the factors that drive groundwater quality change, we'll be looking into salinity. We'll also be looking into that, you know, sea level change and rise from overpumping along the coast or just basic intrusion, and then factors of recharge that affect groundwater quality as well.
Great. I see Andrew, you got your hand up.
Yeah, I just had a question kind of for the whole group, for all of our presenters, and thank you to everybody who presented today. There are a lot of really informative presentations and a lot of really good stuff. So I have a kind of a question and a corollary. The question is how can we better coordinate in terms of data collection between all of these efforts and others? And so that's sort of a question for anybody. And the corollary to that is, how do we best deal with disparate groundwater data so that we can, you know, that we can use it in the ways that Dory was presenting?
If I could take a quick stab at one aspect of that answer would be, you know, now we were first funded by proposition funding. Now we're funded by waste discharge permit funding. So these are fee payers. When we meet with the public and our advisory committee, we always like to make sure, you know, most of the people on our advisory committee are fee payers. So a lot of our discussion does revolve around, where are you required to test? Where is testing kind of redundantly done over and over again with different programs? So where can we be beneficial with your fee money to be testing in other areas or other issues that you don't see fit? So that's an exercise that we do perform quite often.
Any other speakers want to kind of weigh in on Andrew's question about disparate monitoring going on? All right. Well, I appreciate the question. Any other questions for Dory or any of our speakers before we move on to kind of thinking about our next meeting? All right. See, thanks, Dory. I appreciate it.
No, thank you. Thank you, guys.
Okay, so yeah, our next meeting is September 7th. It's intended to be an in-person meeting, and it's in Southern California at SCORP, to kind of spread the love on locations for our council members that are in Southern California, even though some of them have to drive quite a bit anyway. But I'm open to any topics and ideas. I think this format of where, you know, a subset of council members have a topic that they want to hear about, and then help me kind of I'm losing my train of thought of what words kind of create a meeting that's around that topic and find and identify speakers to kind of create a good agenda has been valuable these last few times. So if there are any that pop into your mind now, we have some time, or just any ideas that folks are interested in hearing about. Maybe something they heard about in this groundwater presentation piques some interest. I've heard a little bit about, you know, from Krista, what they're hoping to kind of learn about with some future research. Some other things I heard when I met with Jen Eckerly was they're doing some work on ocean acidification. So I could try to follow up with Jen if there's something ripe there. I know we've talked about that in the past as well. Even last year, there was some ocean acidification work that I know that Mark was excited about, and potentially with some work that SCORP was doing. So if we're going to be down there, it could be something to talk about, but I'm open to ideas. Caitlin, go ahead.
Hi, just on the ocean acidification, just flagging the statewide nutrient management workshop that was held by DWQ. So Karen Mogus and others within DWQ. Gosh, it may have just been last week or the week before. I apologize. It's fairly recent, but I think there is some great follow-up from that conversation where there was presentations of the nutrient management approaches within the San Francisco Bay, but then also building upon the model that SCORP has developed, funded by OPC for the Southern California Bight. But there was a question that came up during that workshop regarding what actual observation and monitoring is taking place. And OPC does have a project and pilot with SCORP as well. So that's one I would highlight as an opportunity to look also into observational data. I mean, it's very nascent, but certainly looking at Southern California Bight, looking further up the coast, there's efforts in San Francisco Bay within Region 2. So those are two that come to mind when it comes to actual observational data, as well as making sure it's a continuation of that conversation too.
Oh, thanks, Caitlin. Lorian.
So it was actually my question at the nutrient workshop a couple of weeks ago at the State Water Board about what the observational data is, and I'm very interested in hearing more about that. Unfortunately, our next Water Quality Monitoring Council meeting conflicts with a BAQUA event, so I'm not going to be able to attend. So I'm going to selfishly ask that, yes, we talk about ocean monitoring and maybe delay a little bit if that's all right with everybody.
Yeah, and I'll follow up with Jen too. She might have had a conflict as well, so maybe I can follow up. Maybe there's a better date if there's multiple people that are having conflicts, and that's the topic folks want to hear about. But certainly, yeah, if this is something observational data, I didn't attend the nutrient management program meeting, so I wasn't aware of it. So open to other topics. Grant, go ahead.
I was hoping Steve Weisberg was still on, but I don't see him. He may have had to drop off, but had the pleasure last week of attending the SCORP 9th Biennial Symposium, which they hosted, I think just last Wednesday. So got a full day of presentations on a lot of the work that SCORP is leading, and just thinking about, taking advantage of being at SCORP on September 7th. I think there's a ton of great topics. Just to throw a few out there that we heard about during the symposium last Wednesday, regional monitoring, both bioassessment and a relatively new regional monitoring program, which SCORP is leading the development on. It's actually a effort led by the Stormwater Monitoring Coalition in Southern California, but that's regional BMP, stormwater BMP monitoring. They're developing a network of monitoring, structural BMPs throughout Southern California that capture, treat, infiltrate stormwater runoff. So those are two, potential topics. There's also a lot going on with microbial water quality. We heard, the other one is ecohydrology. We have the California Environmental Flows framework work group, and a lot of good projects underway and within that work group, and the SCORP team is leading some excellent work in the area of eco hydrology. So I think probably hit just a very small fraction of what we could potentially hear about from the SCORP team on September 7th. But I think those are just a few ideas I had, ideas I had coming out of the symposium last week.
No, I appreciate that. Yeah, it's a good point. And then Steve mentioned the eDNA work that Susie's doing, getting
an
update on that would be interesting as well. Have a SCORP roadshow. I'd feel bad even though they just had one, but maybe there'll be more ripe stuff to talk about. But I'll definitely follow up with Steve to talk about that. Lauren, is that a residual hand? I think it is, Lauren. Probably. Yeah. Okay. Well, with that, I don't want to take up your time. I appreciate it. I'm sorry. I know these are usually maybe a shorter than 3-hour reading, but I thought the talks were great, and it was great to hear about something that we don't really, at least I don't hear a lot about, or not familiar about in the monitoring space, about all the great work that's being done in the groundwater space. So thanks to Mark and Andrew for helping coordinate this meeting, and thanks to all our speakers. And I'll be following up about our next meeting. So with that, have a great rest of your day and weekend. Bye.
Thanks, guys.
Thank
See
you.
later.
Thanks, Nick. Thanks, everyone.
you.
Great presentation.
Nick.
Thank you.
Thanks, everyone. Bye.